SD-Access classes, remember that there is no official certification for the SD-Access. There is an official certification for SD-WAN. There is an official certification for routing. But when it comes to like SD-Access, like there is no dedicated, certification. There's one like there is one content that is available on Cisco, but that is only for the partner side. Like that is more for the sales candidate, sales people and all. So what we are going to cover actually is going to focus on the CCIE Enterprise Infrastructure curriculum. So if I show you like CCIE EI lab exam content, like so let me brief you like what topics we are going to cover in the SD-Access. So SD-Access is part of like CCIE Enterprise Infrastructure version 1.1. Like here we have the content of the SD-Access. Here, like if you go to the software-defined networking, here we have the very first topic 2.1. This is like the SD-Access. So our main focus of the content, like main focus we will have on this part actually. This part like Cisco software-defined access. This is like 25% content. Software-defined infrastructure is 25% of the entire content. And in this 25%, we have software-defined access, SD-Access and SD-WAN. So let's leave the SD-WAN part for the moment. The SD-Access part contains like these 5-6 chapters. So in the SD-Access, we will talk about the underlay, we'll talk about the overlay. What is underlay? What is overlay? How can we build the underlay? How can we build the overlay? Underlay related concepts, overlay related concepts such as manual underlay, automatic underlay, device discovery, extended nodes, pulse extended node. These are like components of the underlay that we had talked about. Then overlay, what is this overlay network? How this overlay network is built? What are the protocols used in the overlay network such as LISP, BGP, VXLAN, cross-sec, layer 2 threading, native multicast? Like these are the concepts of the overlay. So we'll talk about the overlay network. Then once the underlay is prepared, once the underlay is created, and we will talk about like how to create the fabric. Fabric basically means like in one location we are going to configure, we are going to create a software-defined fabric, software-defined LAN, software-defined access actually. So what is this fabric? How can we have a fabric in one site? How can we have the fabric in multiple sites? What is this fabric in a box feature? How can we interconnect those two sites fabric? Let's say, for example, here is one of the campus location, and here is another campus location. Here, this is software-defined SD branch. Like this is SD branch. This is also software-defined branch. So how we are going to connect these two SD branches, software-defined branches together? And maybe what if like we have a traditional branch, how we are going to have the connectivity with the traditional branch? So that we will talk about. So fabric, like the overlay concept, how we are going to have the LISP BGP running in the overlay to create a software-defined access fabric. And then once we have talked about the design, then we will deploy the fabric, where we will talk about the host onboarding, authentication template, port configuration, multi-site remote border priority, whatever these things are. Right. So fabric deployment basically means like, once we have designed our SD fabric, software-defined fabric, then we will deploy it. Whatever concepts are there in the fabric deployment, such as host onboarding, authentication template, configuration, all these things. These we will talk about as the deployment part. This is the one that we are talking about. This is like how we are going to connect like the multiple SD branches, or how we are going to connect the software-defined branches with the traditional branches and all. What is this handoff concept? How can we have the IP-based handoff? How can we have SD-WAN based handoff? What is this fusion router? What is this layer 2 border handoff? We'll talk about all. And finally, segmentation. Segmentation basically means policies and all. So at the very end, we'll talk about the policies. Policies basically means like we will talk about like how can we configure the ICE, how can we create the policies from the identity, and how can we push those policies onto the devices. The total like 6 parts is there. Just a second. Yes.
I was just asking, like, for the lab part, are we going to do on a EVNG, or
No.
will we get any
Yeah,
access
I will brief you about the labs. How we can do the labs. I will brief you about the lab just in a moment. But this is the content that we will focus on actually. Right. So this is the content that we will focus on. This is like software-defined access. This is SD-Access. So this is like the content that we have in the CCIE Enterprise Infrastructure curriculum. So underlay, overlay, fabric design, fabric deployment, then handoff, and then finally the segmentation. These are like 5-6 topics that we have as a part of our SD-Access content. Remember that for the SD-Access, there is no dedicated certification exam. Like SD-Access is specifically part of the CCIE Enterprise Infrastructure lab exam, and also it is part of the NCORE exam. So if I show you like the NCORE exam content, so if I show you like NCORE exam, this is like this, the more like the written exam for the CCIE. So if I show you the NCORE exam, in the NCORE exam also, we have the similar content, exactly same content here as well. So if I go to this, there is a topic called architecture right here. So this is like explain the working principle of the SD-Access design, what is like the SD-Access, how the SD-Access operates and all. So this part is basically also this SDA part, this small SDA part, one chapter is basically in the NCORE content as well, right? So this is what we will focus on, and then this is what we'll focus on as a part of our content. Once these parts are done, then we will talk about some additional topics, such as, for example, we will talk about some wireless, some access points. We'll talk about some ICE, like those things will be added. Those things will be covered like additionally, right? So this is the main content that we will focus on: how to create the software-defined access network, SDA network. What is this SD branch? What are these different roles and everything? And then in addition, we will talk about at the very end. We will talk about like the concept of wireless. Like we'll talk a little bit about the wireless. We'll talk about the concept of like ICE and policies and those things we will cover at the very end. So, but this is the main content that we will focus on. Like it is there is no certification exam for the SDA, but this is part of just the CCI content. So this is the content that we will focus on. Right. So any doubts in the content from from the content level? If you have any questions, you can ask. Let me know. They're just from the content. Like this is what we will focus on. So we will design our network. We will design our network. Then we will configure it. We will design our network, then we are going to configure it. We are going to configure the software-defined access. We will configure the SDA thing in our, curriculum.
So when you say there's no lab exam, does that mean that there will be no configuration requirement within the lab?
No. It's like there is no certification exam for the SD access. Like, for example, in SDA, we have a dedicated certification exam, right? ENSDWI.
Okay. Yeah.
But there is no dedicated certification exam for the SD access. There is one certification exam. There's one exam, but that is more like for the sales people. Cisco has like some internal training for the same. There's one content, but that is more like from the sales point of view. Apart from that, like SDA, they will ask in the exam. Definitely, they will ask in the CCI lab exam. But they will ask you, like, they will not ask you to deploy like everything from the scratch. Only a few things, such as like create a policy on the identity service engine or create a policy on the DNAC. Basic things they will ask. They will not ask like a lot of like from the configuration point of view.
Okay, thank you.
Right. So this is the content that we will cover. This content specifically focuses on the SDA. Then after, like, once we are done with that, then we will focus on the content of the SD-WAN, which is a different classes. So in the SD-WAN, we will talk about the same thing, but from the WAN point of view, like how can we deploy like multiple WAN-edge devices, and we can manage those from a centralized point. So that is like SD-WAN. So this SD-WAN and SD-Access in total, it gives you 25% content of your software-defined infrastructure. So this is what we will call, and there is a book for the same. Like there is one book that we can go through. The book is basically this one. This book you will get on the portal actually. So this is the book. This is the official book from the Cisco. It's not the official certification guide. It's just a book. It's just one official book from Cisco that we can go through. So this is the official book from the Cisco for Cisco Software-Defined Access that you can go through to get like more detailed knowledge. There are like total 9 chapters. Chapter 1 focuses on like why we need SD-Access. Chapter 2 focuses on introduction to SD-Access. Then chapter 3 focuses on the controller used in the SD-Access. Then chapter 4 focuses on the SD fundamental, identity services engine, then troubleshooting operations, some advanced SDA topics, DNS center, advanced DNS center, assurance. So there are 9 chapters that we can go through. In some chapters they have focused on like why do we need like SD access, why do we need software defined networking, and then they have focused on the content like what is software defined access, what is the DNS center, how we can deploy the DNS center, how can we have the how can we deploy the switches and all. So all that thing is focused in these 9 chapters. They have also covered like very much about the identity services engine, what is ICE, how can we integrate the identity service engine with the DNS center, how can we create the policies and all. So all that thing is described in these 9 chapters. So this is like much more detailed book. Half of this book is just focused on like why have we created the DNS center, what is the use of the DNS center. So half of this book focuses only on that thing, like what is DNS center, why have we created the DNS center, and also that you can go through. Otherwise, we do have one more book. This book is like more, I would say this is more like cut to cut book that we have. If you want to just, it is like just like some 190, 180 pages, I guess. Like there are not like a lot of pages in this book, so I guess like 168 or 160 pages like are there. And this book focuses more on the technical aspects of the SDA. It's like what is just the basic introduction, why we need SD access and all, and then after like they just started the technical discussion. So it is much more like if you want to go through the content in more like a summary format, you can also go through this book actually. So this is like one more book. Both books will be available to you on the portal, so you can download it and you can read it. You can go through it actually. So it's not the official book. This one is the official book from Cisco. This is the official book from the Cisco, and this is more like the just a normal book. Some people have written this, so it focuses more on the content rather than saying like why have we created the DNS center, what are the uses and everything. So more like cut to cut book, like this is more like they have talked about the content in more precise form. So that is, if you want to go through in very detail, then go for it. If you want to just cover the content in summary and also, and then you can go through that one as well. Right. So both of the books will be available. You can refer to the content from these books. We will try to cover. We will cover basically all things that we have here in this book, all the chapters, all the topics that we have here in this book. We will cover it. Everything that we have in this official book, we will cover it. Apart from that, we will also cover the wireless. We will also cover the access point. We will also cover the identity services engine. By ICE, I mean we will cover like how to integrate the ICE with the DNS center and how can we create the policies and everything. Like so we're not going to cover like the ICE from the scratch. Like it's not like we will cover complete identity servicing. ICE is a dedicated content that is covered in security. So there is a dedicated certification for the ICE, like SISE. So security identity services engine. So this is a dedicated certification for the ICE in the security track. So we are just going to see the basic components of the identity services engine. We will see how can we integrate the identity services engine with the DNS center, and we will see how can we create the policies for the network access, and how can we create the policies for the user authentication on the identity services engine. That is what we will focus on the from the ICE point of view. So it's not like we are going to cover ICE from the scratch. For that, you have a dedicated certification, you have a dedicated course for the same.
ICE or AAA server are same.
Like AAA services are nowadays managed by the ICE. So when we talk about the AAA, we will do the things on the ICE itself. So like we will create the authentication authorization rules on the ICE. So we'll do AAA, but we'll do AAA on the ICE itself. Like we will not talk about any other AAA servers and all. So that's why we will cover a little bit about the ICE, the introduction of the ICE, why we need ICE, how can we deploy the ICE. The basic things we'll talk about the ICE, but it will not be like A to Z complete content of the ICE. That is not going to be there. Our content focuses more on the integration of the identity service engine with the DNS center, and then how can we create the policies and everything. So, right. So, but the dedicated content of the ICE is actually covered in this certification, the security ICE, like CCIE certification, which is again part of the security. Similarly, we will, when we talk about wireless, I will not talk about like A to Z complete wireless. I will just talk about like what is WLC, what is access point, how WLC, how APs connect to the access point, and we will directly come to the point like how DNS center is going to deploy the WLCs and access point in an automated fashion. So it's not it's this content that we have, this SD-Access content, it's not a associate, or it's not a beginner level content. Like you should have some basic understanding of the things, such as like some basic understanding of the switching you should have, some basic understanding of the wireless you should have, some basic understanding of the security you should have, some basic understanding of the design you should have, like design like 2-tier design, 3-tier design, core access distribution, that thing that we have in the switching. So some basic things you should know. Then like we are going to just see how can we deploy the WLC, how can we deploy the access point via the DNS center, how can we integrate the identity service engine with we'll focus on that part. It's not like we will cover everything from the scratch. So it's like you should have like some knowledge about like the, for example, when we talk about this topic of handoff, when we talk about this topic of handoff here, it will be required for you to know a little bit about the BGP, border gateway protocol. Not like very detailed, just the BGP basic, like how the BGP forms the neighborship and everything. Here you should have the understanding of a little bit SD-WAN. Even if you don't have it, like we will discuss it, but like what is SD-WAN? Why we need SD-WAN? So some basic things about the SD-WAN you should know. When we talk about like wireless integration, you should know a little bit about the wireless as well. So what we can do, I will provide you some videos of the wireless and everything that you can go through before our classes start. And then when we start the wireless part in our SDA content, then those things will connect like properly. So like you should have some like some knowledge. There is some prerequisite that you should have some at least understanding of the basic terminologies, basic things from the content. Basic concepts, like at least you should know basic contents. By basic content, I mean like you should have the understanding of the basic switching, basic design, basic wireless, basic BGP, VRF, basic things you should require. Before the classes, I will let you know. That okay, this is a topic that we are going to cover tomorrow. So if you're completely new to that topic, you can revise it from some videos and all, and then when we discuss in the class, then you can put up the questions. Right, so we will focus on this content. Apart from that, we will focus on the other things that we have, such as wireless, ICE integration, and things. In the exam, it is expected for you to know the GUI, the graphical user interface of the DNS center, which is the controller, which we will talk about that. And you are expected to do a few things on the DNS center. Only one question is there. Only 1 or 2 questions are there, that they ask. So yeah, this content will be enough from the lab exam point of view. This content will be enough from your production point of view. This content will be enough to give you the idea how can we deploy the software-defined branches in our infrastructure. So this will be more than that. Just to give you the idea, SDA is just a component. SDA is just a part of the DNS center. DNS center is the controller. DNS center is the controller, which is nowadays known as the catalyst center. So DNS center is the controller that we use for this SDA solution. We need to purchase this controller. We need to install this controller in the network, and this controller is going to manage all the things from one centralized point. So SDA is just one part of it. SDA is just one tab that we have in the DNS center GUI, and then we have other things as well. Let me show you. So what you can do, you can go to Cisco D Cloud. You can go to Cisco D Cloud, just search Cisco D Cloud, then go to the Cisco D Cloud here. Log in with your Cisco credentials here. Like you have to log in with your Cisco credentials here. I'm going to log in with my credentials. So once you have logged into Cisco D Cloud with your Cisco credentials, you can go to the catalog right here on the catalog. In the catalog, you are going to click on here the D Cloud instant demo. You will filter this like D Cloud instant demo, and either you can scroll down. You can scroll down and until you see the, for example, if you want to see about the route like SD-WAN, you can take this SD-WAN demo. You can see the Nexus dashboard. These are like different demos. Identity services engine like ICE treatment tree. So Cisco Catalyst SD-WAN 20.11. So if you scroll down, you keep scrolling, you can see like these different demos that they have provided. These are like different demos that they have provided. Here you will have the DNS Center, Cisco DNS Center Automation and Assurance instant demo. So you can just click on this. Please use a newer version of this demo. So there is also a new version of this demo. So just click on that. right? And here is the, let me show you. Looks like, this 2.3.7.4, this demo has been removed, I guess, like, that's why we are getting that error. I have bookmarked it, by the way. I have like bookmarked it. So I will go to the catalog, then I will go to the dcloud, I will go to the instant demo, and you can search from here as well. You can search the catalog from here as well. Otherwise, you can just scroll down. At the very end, you will see the dcloud demo actually. No, I already have it like bookmarked. So here is like, I already have it bookmarked. So I will just just a second. Proceed. Okay. So like, you will get this kind of like, you will get this kind of like portal. And here, like, this is the GUI of the DNS center. This is the graphical user interface of the DNS center. And you can see like here, we have just one in the provision. We just have one like, SDA. This is one of the tab that we have in the DNS center. Apart from that, we have network devices, services, policies, design. We have a lot of things in the DNS center. So our main focus of the content will be on this part. We have a lot of other things. A few we will talk about. But still, like, we have a lot of things like SDA. Like, we have this is what we will focus on. But apart from that, we have like other tabs such as device tab, services tab, assurance, design, policy, provision. So we will focus on like specifically on the SDA, but the other tabs that we have, other tabs such as design, how can we design the network, how can we deploy the policies, how can we do the provisioning of the network and all that, we will also cover. We'll also talk about the wireless access point and those things actually. So SDA is just one part of this solution. Like DNS Center appliance that we have, SDA, software-defined access, is just one part of it. And then apart from that, we have other things as well. Like, so this part, SDA part, will focus on creating the fabric side, transits and all that thing, which is part of our content. This is part of our content. Right, so we'll focus on that part, and then apart from that, like, we will focus on the rest of the things, such as like what are different tools available in the DNS center, what are like these APIs, how can we generate the reports and all, how can we deploy the policies, how can we design the network and all. So that thing we will also. Right, so this is like, this is the dcloud DNS center, and whatever things we will do in the classes, like almost, I would not say like everything, but almost like a lot of things you can do from here as well, such as you can design your network from here, you can create the policies, you can do the provisioning, you can configure the fabric roles and everything you can do. Like, this is not only read only, this is not read only, and this gives you like read write both the access. So I would not say like everything, but almost 60-70% thing that we will cover in the classes, you will be able to complete on here actually. And you will have to unfortunately rely on the dcloud or the DevNet sandbox for the lab purpose. DNS Center is not a software appliance. You cannot like run these things on the EVNG. It requires like DNS Center is more like a hardware that you have to have. Then you need to have some physical switches and all. Then you need to create the topology. Then you will be able to practice on that topology. So here we do have physical switches. Here we do have like the DNS Center. I already have built a topology here. I already have integrated the DNS Center and everything in the premises. But and I will do everything on the physical devices. But when it comes for you to practice, you will unfortunately have to rely on the dcloud DNS Center. Almost everything, again, not saying like completely everything, but 60-70%, 70-75%, I would say, whatever things we will do in the classes, you will be able to repeat it in the dcloud. Not everything, of course. For example, you cannot discover a new device and everything, but like, you can design the network, you can create the policy, you can create the fabric, you can create the transit, you can do all that things right from here. A few things, of course, you will not be able to do, such as discovering the new devices, such as, for example, doing this LAN automation and those things. You will not be able to do all that thing, but wireless and all. So But apart from that, like, like I said, like most of the content, like we will be able to practice on the D cloud itself. I will do it on the real devices, but unfortunately for you, you will have to rely on the DNS center. It is when, let's say, someday, like when you start the lab preparation, lab exam preparation, then whatever topics are there in the, from the lab exam point of view, at the time of lab exam preparation, then you will be given the access of the DNS center, and then you can practice on the same based on the task that they have in the exam, based on the content that they have in the exam here. So from the lab point of view, from the lab part point of view, you unfortunately have to completely rely on this dcloud DNS center, or you can schedule the lab on the DevNet sandbox. But I have heard that DevNet sandbox lab is not like that much stable. It takes too long to run. You have to schedule the lab like 1 or 2 weeks before, then you will get the slots and all. So I would just recommend you to practice all the things on the dcloud DNS center itself. So I will, since I have built my own network here, I have some switches, I have the DNS center, I will show you the topology and everything. And then as I design the network, similarly, you can explore the GUI that we have here, and you can design the network. You can design the network from here. You can do the changes in network setting. You have like complete read and write access. You can see, I can add the things, I can remove the things. You can do whatever you want to do here. Like I said, so 70-75%, I would say content you will be able to repeat here. You will not require like any DNS center. You will not require any identity service engine. You will not require any physical switches. You will be able to repeat those things here, but I will do everything on the physical devices. Right. So once you get your concepts clear, then you can practice a few things like here, and later on, like in your production environment, whenever you get the chance to practice on the DNAC, then you can work on that. Later on, when you start the lab exam preparation, then you will be given the access of the DNS center, and then you can practice on these things that they have asked in the exam. That's the approach that we take from the lab point of view, like how the lab is going to be delivered. This is not a software solution, actually. It's not like SD-WAN. If it was like SD-WAN, we would be able to give you the access. SD-WAN is completely like software. We can deploy the things, we can create the labs on the software. But unfortunately, for the SD-Access, that cannot be done. DNS center is a hardware component. Switches that we require, they are hardware. So it's completely like hardware solution. So you will not be able to practice these things on the EVNG or like any other things. So if you have a, maybe if you have a good server that has like 400, 500 GB RAM, and then like 46 TB SSD and all, 4080 core CPUs, then you can deploy the virtual DNS center onto your server, switches and all. But just for the practice purpose, no one is going to do that. So I would say that practice everything that we are doing in the DNS center, dcloud DNS center, and then later on, when you get the chance to work on that DNS center, then do it on the real environment. Again, I'm not saying we can practice everything, but we can practice most of the things here. Yes.
I have one question. Sorry for the interrupt. So DNS center is available for all of us. We can create an account and we can do the practice. Is it?
This one is completely like, this one is from the Cisco itself. This is like demo, but it's not actually read-only demo. It's like read-write both. So such as, for example, you can go to the policy. You can go to the policy and you can create the policy. You can create the security group. You can create the things there. So it's not read-only. It's read-write both.
Okay.
Right,
but
so,
how long the configuration what we are doing, how long it will be there, or it is again after the 24 hours it will get to vanish everything?
As long as you are in the GUI, as long as you are doing the things here, it will remain there. But after that, like as soon as like you log out or as soon as your session expires, those configurations will be gone.
You mean to say all the cleanup is happen once I logged out?
No. All the cleanup, it will be like this, as you are seeing right in front of you. It will be like this. This is the default state. This is the default. This is like the default one. So you can go there. You can create your own, and then I guess like when you log out, like when your session times out, like when you log in again, maybe your configurations will be there, but otherwise they wipe it. They wipe it actually. They wipe the configurations after some time. So the purpose of this dcloud demo is just to get yourself familiar with the GUI of the DNS center. What are the options available in the DNS center? What things you can do on the DNS center? But they have also given us the right access of the same. So you can create your network hierarchy, like you can create the locations and everything. You can do the network settings. You can do like plenty of things up here from the exploration point of view.
Okay. The same GUI will be there on a physical device. If you logged in, if you
Yes,
assign the
yes,
management
yes,
IP, and if you
definitely,
assign, so
definitely,
same GUI will be there.
exactly.
Okay.
I will, in fact, I will show you that as well. Like, I will show
Mhm.
you that when we practice, when we start practicing on the when I will when I will do the labs in the premises, I will show you that it is exact same GUI, and we will be working on the version that they have asked in the exam 2.3.5. So this one is currently, I guess, yeah, 2.3.5. This is the version that they have in the exam. This is this is the software requirement for the exam. So we'll be practicing on the exact same version 2.3.5. But we do have like physical appliance here, so I will be showing you things from the scratch on the physical appliance. You can just understand the concepts and everything, and then you can practice like plenty of things on here on the D cloud. Not everything, again, not everything, but plenty of things you can practice. You can repeat the recordings, you can refer to the documents to get more understanding. You can ask the questions and all. So you will get like more and more clarity as as we proceed through the content, and then you can practice the things on the D cloud DNS Center. That will be this will cover, honestly speaking, like from the lab exam point of view and everything. This is sufficient. This is enough actually. Like all the things that they've asked in this part. Like you can practice like almost everything in this D cloud DNS Center. So, but the restriction is that you cannot create your own topology. Restriction is that you cannot discover a new device. A few things you will not be able to practically do, such as, for example, LAN automation and everything. But still, like if you click on the LAN automation, if they have you can click on start LAN automation. You can do the things still. You can still do the things. But the problem is that we might not be able to do everything, right? So this is from the so when we talk about like like network design in a traditional network design, how can we build a network? How we generally build a network? We either follow this from the design point of view. We follow this like two-tier architecture, or we follow like three-tier architecture. Not compulsory that we have to follow, but ideally, like from the design point of view, it's recommended that you either have like two-tier hierarchy or you can have three-tier hierarchy. In the three-tier hierarchy, what we have like this thing called access layer. Then we have this thing called distribution layer. Then we have this thing called like core layer. Then we have some routers, maybe firewalls and all. And the design becomes something like this. So this is going to be like access layer, switch 1, access layer, switch 2, access layer, switch 3, access layer, switch 4, distribution layer, switch 1, distribution layer, switch 2, core layer, switch 1, core layer, switch 2. Here we have our end users connected, like here, VLAN 10, 20 and all. And here we have like our distribution layer, which is like the aggregation point of the access layer devices. All the access layer devices, access layer is responsible to connect our end users. Our end users are connected at the access layer switches. Then those access layers are aggregated at the distribution layer, and then those distribution layers which are aggregated or connected via the port layer. So in the three-tier hierarchy of the design, from the design point of view, in the three-tier hierarchy, we have three layers. Like we have like the access layer, we have the distribution layer, and then we have the core layer. And then core layer devices, they connect to the outside, like they connect to the routers, and the routers can connect to the outside network such as internet, and maybe the router is connecting to outside network such as our other branches like data center, headquarter, and all that. So we might be connecting to other branches such as branch 1, branch 2, data center, headquarter, and all that. So we might also be connecting to the our other of the branches, and we might be connecting to the public network such as internet. So from the design point of view, when we design our infrastructure, when we design our campus area network, when we design our campus area network, campus could be like anything. It could be like college campus. It could be like enterprise campus. It could be like any campus. So from the design point of view, this campus area network, this CAN, it consists of like either three layer. Three layer basically means like access layer, distribution layer, and the core layer. And then at the access layer, we will have switches. On the access layer, we will have the switches that will connect to our end users. Our end users are going to connect at the access layer. Our end users are going to connect at the access layer. And then the aggregation point, those access layer switches are connected via the distribution layer. Distribution layer is basically responsible to connect all these access layer devices together and send the traffic from one access layer to the other access layer, from one device, from one user to another user. And if you have like a very big campus network, then we can also introduce this thing called a core layer. Core layer will be responsible to connect like multiple buildings, like or multiple campuses all together. So core layer, like three-tier hierarchy, three-tier network is going to consist of these three layers of the design, each layer has its own set of functions. Like at the access layer, we are going to have our end users connected. Distribution layer is going to be the aggregation point of the access layer devices. Then the core layer is going to be the aggregation point of the distribution layer devices. Typically, we require the core layer. Typically, we require the 3-tier hierarchy in a very big campus network. If you have a small campus network, then you don't need to go for a dedicated core layer. You can just have the access layer. You can have the distribution layer, and you can directly connect your distribution layer devices with the core routers and all. And core routers are going to connect to the internet. Core routers are going to connect to the other branches and headquarters and data centers and all. So we can also have like 2-tier design. Completely subject to the amount of traffic, the number of devices that you want to connect, the number of buildings that you want to connect. Completely subjected to the design. Are we going to have a 2-tier hierarchy, or are we going to have the 3-tier hierarchy? Now, it does not matter if you go for a 2-tier hierarchy or if you go for the 3-tier hierarchy. If you go for core access core distribution, access distribution core, or you go for like only access layer and core distribution layer. This is called core distribution. Core distribution, we call that because the functionalities of the core layer are also combined with the distribution layer. So either we can have like, this is also known as the collapsed core. Collapsed core design. In the collapsed core design, the functionalities of the core and distribution layers are collapsed to each other. So either we can have like 3-tier design, we can have 2-tier design, whatever. You can go for 2-tier, 3-tier, whatever. Based on the requirement, you can go for either 2-tier or 3-tier design. No matter if you go for like 2-tier design or you go for 3-tier design, there are certain challenges. There are certain, I would say, issues that you will face in your traditional campus area network deployment. In a traditional campus area network, a deployment configuration operation, you will face of certain challenges. Such as, let's say you will face the challenges in a traditional network, you will face the challenges regarding the deployment. Deployment challenges basically means like, let's say, for example, we have to set up 3 branches, and in all the 3 branches, we have to set up the 3-tier design, like, the access layer, distribution layer, and the core layer. So first of all, you are going to purchase the switches. You are going to purchase all the necessary devices. You are going to purchase the switches. You are going to purchase the routers. You are going to purchase the firewall. You are going to purchase like all the cables, connectors, whatever. You are going to purchase like all the devices, and then you have to deploy those. Like you have to, connect all those devices together. And then once you connect all those devices together, then you are going to configure each and every device like one by one. I will do the configuration on the access layer. I will do the configuration on the distribution layer. I will do the configuration on the core layer. Then I will do the configuration on the router. Then I will do the configuration on the firewalls. I will make sure that our campus network is reachable to the outside network, such as internet. I will make sure that our campus network is reachable to the outside network, such as our data center, headquarter, branches, and all that. A lot of manual configurations will be required. So, and similarly, you have to set up now the 2nd branch. Similarly, now you have to set up the 3rd branch. Similarly, now you have to set up the 4th branch. If you have like multiple branches to set up, if you have to like set up a few branches like from the scratch, you will see that there will be some administrative overhead in deploying those branches, in deploying those devices from the scratch. You will require to do manual configurations on all the devices, and when you do the manual configurations on the devices, there are very good chances that you might make some mistakes in some of the device, like that will affect the routing, that will affect the switching, that will affect the reachability. Devices might not connect to the other devices, and also you will face plenty of challenges from the deployment point of view. Not to mention, what if I do not even have all the Cisco devices? What if I have Cisco devices along with the Juniper devices? Like, what if I have Cisco switches and then we have some other vendor switches as well? What if I have Cisco routers and I have Juniper routers? What if I have a Juniper firewall? So box by box, like you have to take the access of the device, box by box management you have to do of the device. You will have to do the configuration on box by box basis, which will add like more and more overhead onto the administrator. So when we have to deploy a campus area network, you will face certain challenges in the deployment, challenges regarding the configuration, challenges regarding the manual overhead that we get on the administrator regarding the deployment of the devices. Okay, once everything is deployed, everything is fine. Like we have deployed all the devices, we have made all the devices reachable to each other. We have made all the devices reachable to the internet, data center, headquarters, everything is working fine. All things are reachable to each other. How are you going to enforce the security now? The requirement is that HR department user should not be able to communicate with the finance department. Finance department user should not be able to communicate with the IT department. We have certain requirements. We have the requirements that we have in our campus area network. We have like some departments, and we are required to configure the network in such a way that some devices are able to communicate with some devices and some devices are not able to communicate with some devices. Let's not even talk about a college campus. In a college campus, we have like branches, like CSIT, whatever. Then we have in every branch, we will have like first year, second year, third year, fourth year. Maybe like we will have like HOD, we will have like different departments in the placement team and all that. We will have like different departments in the college campus network as well. We will have the different departments in the enterprise network. We will have the different departments in the campus network, college campus network. We will have different departments. And the requirement is that we have to enforce the security in such a way that some people are required to communicate to each other, some people are not required to communicate with another people. Let's not even talk about the firewall configurations that we have to do. This is just the basic security requirement that I'm enforcing here. So how we are going to make our network secure, that is also going to be one concern. Security means like, are we going to configure the ACL? Are we going to configure the security based on the ACL? Are we going to configure the security based on the VLAN? We can do this kind of segmentation with the help of the VLAN. We can create a VLAN for one department. We can create another VLAN for another department. Those two VLANs will not be able to communicate to each other. That's fine. If the communication is required and we can do like inter-VLAN routing, then we can configure the ACL to control who can communicate with whom or not. So are we going to really configure the access control list? Are we going to, how many number of VLANs are there? 4,000. Maximum like 4,094. 4094 number of VLANs are there. In a very big campus network, those number of VLANs might not be enough. What about the ACLs? In a production environment, you might see the ACLs having like 5,000, 10,000 lines of statements, like, entries. Configuring the ACL, editing the ACL in a real environment is a very hectic task. Because if you just miss one statement and your entire ACL might be deleted. You just miss one such port trunk allowed VLAN and you just miss add keyword and everything will be gone from the trunk. So configuring the security, enforcing the security based on the ACL, enforcing the security based on the VLAN is not a very scalable solution. We can enforce the security based on the ACL, we can enforce the security based on the VLAN, that is fine. In a small campus network, that is fine. But in a big campus network, like, such as a college campus, such as a very big enterprise campus, configuring the security purely based on the ACL VLAN is not going to be a very good task. What about the security of the traffic that is going outside the network? What about the security of the traffic that is coming from outside, from the internet to the inside? So we do need to deploy some firewalls, some IPS IDs, some those security appliances, and we need to manage those devices individually as well, manually. Everything is manually done. So you will face some challenges regarding the security as well. You will face some deployment related challenges, then you will face some security related challenges, then operational challenges. Once, let's say you have done the deployment, let's say you have done the deployment of the devices, let's say you have made the reachability, let's say everything is working fine, let's say you have also enforced the security, everything is working fine. Then someday some user reported that they are not able to access the network resource. Some issues there. So now you will go to like the devices and you will have to do the troubleshooting and everything manually, one by one. Like, step by step, you will do the troubleshooting. Okay, you're not able to access the services. Okay, can you ping the gateway? Okay, gateway is reachable. So from the gateway, can I ping to the destination? No, that is not reachable. Where the route is not coming, like, we have to troubleshoot one by one, step by step, using the tools such as ping, trace, all those things we are going to do. What about like Cisco or vendors, they release a software upgrade and we have to upgrade all the devices that we have in our campus fabric. We have to do the software upgrades on the access layer devices, software upgrades on the distribution layer devices, software upgrades on the core layer devices, software upgrades on the routers, firewalls, everywhere. And that again, we have to do one by one manually. So if you want to perform the software upgrades and all that, those will also come in the operational challenges. So those things we are also going to do manually. What about the monitoring? Like, we are going to use some monitoring tools, and using that monitoring tool, we are going to monitor our entire network. So if some interface goes down, we will set up things such as email alerts. So if the interface goes down, I will get the email like, okay, this interface has gone down. We need to fix that. Monitoring is also going to be like in one branch. I am seeing that the traffic utilization is way too much, and we need to find out like who is accessing the traffic at that rate. Like why that application, why that YouTube traffic is so much, and what we can do about it actually. So we will need to use like variety of monitoring tools, different monitoring tools companies use to monitor the entire network. Companies have different tools. Like Wipro might have different tools, like Infosys might have some different tools, other companies might have some different tools for the monitoring purpose. What about like cloud and all? What about nowadays everything going to the cloud? Like we have deployed our applications onto the cloud. We have deployed our infrastructure onto the cloud. How we are supposed to connect? How we are going to improve the user experience for the applications that is hosted on the cloud, such as for example Office 365. What about the CRM application? What about the Dropbox? What about these like cloud hosted applications? So we have a user sitting at home, or we have a user sitting in the premises, office premises, and the user is trying to access the Office 365, which is hosted on the cloud. And user is reporting that the user experience is not good enough. Like when I'm typing, it is taking some time to type actually. Or maybe it is the user is trying to access some CRM application, and the CRM application is basically loading slow. Why? Because this application is hosted on the cloud, and the way the traffic is passing from the user PC to the cloud is basically there is a lot of latency, there is a lot of like drops, and those things are there. What about like, so how can we improve the user experience for the applications that are hosted onto the cloud? What about like how if I have hosted an infrastructure onto the cloud, like I have my cloud hosted data center. Companies, they have like instead of running the appliances onto the premises, companies can host their appliances onto the cloud. So like what if I have a cloud hosted infrastructure? Infrastructure as a service is a very popular concept in the cloud terms. So what about if I have hosted some infrastructure onto the cloud, and now we want to extend our campus fabric, we want to connect our campus fabric to that cloud hosted infrastructure. Maybe I have a cloud delivered firewall, and I want that my traffic should go securely to that firewall, and from that firewall, it should go to the other devices. Manual configurations will be required again. Then. What about IoT? What about Internet of Things? Cloud isn't other, but IoT is visit Internet of nowadays. Like everything is being connected to the internet. You can control your smart home appliances from your from your mobile phone nowadays. So what about the IoT devices? IoT devices, they continuously, they regularly interact. IoT devices, sensors, and everything that we have deployed in our network. So how are we going to manage those IoT devices, sensors, one by one, those things? What about the wireless network? Let's not even talk about the wireless. A campus is not only going to use wired, but also the wireless network. So what about the wireless access points? We have like thousands of access points we have, let's say, hundreds of access points in our campus fabric, in our campus network. And of course, we are not going to manage all those access points one by one. So we have deployed a wireless LAN controller, which is responsible to manage all these access points from one centralized point. So are we going to configure all those things on the WLC manually? We have to onboard the access point. We have to onboard the WLC. We have to configure the WLC. We have to configure the AP. Then only AP and WLC will be able to connect, and then we can manage the things from the wireless LAN controller. So WLC is also controller. That is WLC, wireless LAN controller. It is a device that is responsible to manage all the access points from one centralized point, so that we don't need to manage each and every access point one by one. So like if you have hundreds of access point, what user is connected onto what access point? How can we get that detail? And what if the user is roaming from one point to other point? How the roaming is going to be ensured properly, and all. A lot of wireless challenges are there. So overall point is that the traditional network that we have, traditional network like the traditional LAN network, traditional WAN network, traditional network that we have, a traditional campus area network in from the deployment to the operation to the monitoring to everything, like we do have like certain challenges in the traditional network. We have challenges regarding the deployment, challenges regarding the security, challenges regarding the monitoring, challenges regarding the operations, the cloud, IoT. Like we have a variety of challenges in the traditional network, troubleshooting and all. More and more human resources are required to all these things. If you have to deploy like 3-4 branches, and in those 3-4 branches we have to deploy like 6, 7 switches one by one, a few routers one by one, it will require more and more human resources, which is good from the human point of view, but from the company point of view, that might not be a very cost-effective solution. Then troubleshooting, software upgrade, those are like other challenges that you have in the traditional network. We have like in traditional network, we have like plenty of challenges. Same challenges goes for the WAN edges, routers. Now, so we have built our campus fabric. We have built our access layer. We have the distribution layer. We have the core layer. That is fine. And now we are required to actually connect our campus network to the internet. We are required to connect our campus network to our data center headquarters and all things. So for that, we are going to connect some routers at the edge, or maybe we are going to connect some firewall at the edge. And then we are going to terminate our internet connection onto the firewall. We are going to terminate our MPLS connection onto the router and all. So how, if we have hundreds of branches all over the world, and on every branch we have 2 managed routers. So managing all those 200 managed routers one by one, doing the SSH, telnet and everything for the management purpose is again going to be a challenging task. Point is, in a campus area network, in a traditional campus area network, we have the challenges from the LAN and actually WAN point of view. LAN basically means like access, distribution, and core, and WAN basically means the edge routers that we have. So they thought, why don't we not use humans for all these tasks of deployment, troubleshooting, monitoring, security enforcement and all. Why don't we not use like humans for all these tasks? Why don't we use some softwares for this purpose? Let's create a software. Let's create a software that is basically smart enough to handle all these problems that we are having. Let's create a software that is able to deploy the router switches in an automated fashion. Let's create a software that is responsible to enforce the security policy in the network from one centralized point. Let us create a software that is going to give us the overall idea of the network from one single dashboard, like monitoring for the monitoring purpose. Let's create a software from where we can push the software upgrades onto the devices just in one go. Like we don't need to log into each and every device one by one. And they did that. They created a software which is responsible to automatically configure, provision, monitor your network from one centralized point. And this thing came out in the data center network for the very first time. In the DC data center infrastructure, they started using the software to manage the data center network from one centralized point. In the data centers, like in the DCs, in the data center, they started like deploying the software-defined networking. So in the data center, they created a software and they started managing the data center network with the help of that particular software. And of course, you know that software is going to be installed on some hardware. We have to install the software on some hardware. So that hardware that they created, that hardware which is responsible to manage all these things from the centralized point, that is known as the controller. Such as wireless LAN controller. Wireless LAN controller is a device that is responsible to manage all the access points from one centralized point, all the APs from one centralized point. Similar to that, they created a software, of course, that runs on certain hardware, which is what we refer to as a controller. A controller they created for their data center network. They created a controller for the data center network, which is responsible to manage all the DC infrastructure from one centralized point. And they named it what? EPIC. Application Policy Infrastructure Controller. EPIC is the name of the controller that they use in the data center environment to manage the data center infrastructure from one centralized point. EPIC. They use this concept called, ACI data center. What is this ACI? ACI stands for Application Centric Infrastructure. All the data centers that we have, all the DCs that we have, all the data centers that we have, they are built around the application. They are built around certain application that they serve, such as, for example, like Facebook data, such as, for example, You might be running certain application in your data center, and your customers are going to access that application, such as like mobile banking, for example. There will be some servers. Those servers will be running that application that users are basically accessing from their mobile devices, like SDFC, SBI, net banking applications, and all, for example. Maybe your company is providing certain services to the customer, and those services are running onto the data center, such as, for example, Facebook, Google, Google Drive, for example. You upload your files on the Google Drive, and they remain there forever. So those files are getting stored somewhere. Those files are getting stored in the data center. So someone is responsible to manage that data center infrastructure. So data centers are built around certain applications that they serve. That's why we call them ACI data center, application centric infrastructure. We call DCs as ACI, application centric infrastructure, because they are built around certain applications that they serve. And to manage the ACI data center, they created a controller called EPIC. EPIC stands for Application Policy Infrastructure Controller. EPIC was the centralized controller for the data center infrastructure. And still it is in a modern network, still this ACI EPIC concept is being used in the data center environment. We still build our data center following the ACI concepts, application centric infrastructure concept, and we manage the data center network with the help of this EPIC, Application Policy Infrastructure Controller. EPIC is the name of the controller that Cisco created for the data center network. It was very popular. Like, it is in fact very popular nowadays. Also, we use it. So they thought, why don't we use the same for the enterprise network? Why don't we use the same for the campus area network? And they did that. They created a controller for the enterprise network, which has the same purpose, as the EPIC, actually. They created a controller for the enterprise network. This was the data center for the ACI data center. They had this for the ACI data center. They created this controller called EPIC, Application Policy Infrastructure Controller, and then they actually created the similar kind of controller for the enterprise network, for the campus area network, for the enterprise network. They created a similar kind of controller. Way back, way long back, they created the controller, and the name of that controller was EPIC EM. EPIC EM, Application Policy Infrastructure Controller Enterprise Module. These were two different products. This is a different product. This is a different product. This is a different controller. This is a different controller. This is for the data center. This is for the enterprise network. EPIC EM, Application Policy Infrastructure Controller Enterprise Module. EPIC EM. EPIC EM was a centralized controller. EPIC EM was the controller for the enterprise network, actually. Unfortunately, that controller could not gain a lot of popularity as the data center EPIC actually gained, actually. So EPIC EM could not gain that much popularity as EPIC. Sooner, companies, they nowadays Cisco, they do not sell the EPIC EM controller. EPIC EM was soon more obsolete. Cisco do not sell this EPIC EM controller nowadays. So EPIC EM was the enterprise SDN controller. Like the EPIC EM was the SDN controller for the enterprise network. Another controller that we are currently using in the enterprise network for the same purpose, for the almost same kind of purpose, not exactly the same, but another controller that we are very popularly using in a modern day network, currently we are using in the enterprise network, is known as the prime infrastructure. Prime infrastructure is a very popular controller that nowadays we are using in our enterprise infrastructure. So modern day enterprise means current campus area network, they use this controller called prime infrastructure, which soon will be obsolete. Soon, it will be obsolete. You see, they have already announced end of sale, end of sale, for that prime infrastructure. This is the controller. This is like the Cisco Prime infrastructure. So it is no longer orderable nowadays. So this is it was released in 2012. Okay, 2023 end of sale, and it will go end of support in 2028. Sooner or later, you will go for the SDA. When people are migrating from the prime infrastructure to the DNS center. So you will currently we do have like prime infrastructure 3.3, 3.4, 3.5. We do have it. So 3.3, 3.4. So they do have like 3.10 release, but it is no longer orderable. So it will go like end of support in 2028. So this is just another controller. This product is supported by Cisco, but no longer being sold. Consider switching to the DNS center or Meraki. So they say we can use like these, we can use it, but you like this prime infrastructure controller is no longer being sold. So if a company is using the prime infrastructure, sooner or later they will migrate to the another controller, which is what we refer to as the DNS center. So this prime infrastructure PI prime infrastructure is one of the controller that nowadays currently we are using in our campus area network. I guess I can show you, not sure, prime infrastructure, if I can show you the demo of it, not sure if the Cisco prime infrastructure, if I say GUI, not sure if they will. So it is something like this. If you go through the prime infrastructure, if we go for this Cisco prime infrastructure GUI, so we get like this kind of GUI, this kind of graphical user interface. And this is the kind of like GUI we get, and from here we can manage like the campus area network from one centralized point. So you can just scroll down and you can see the user interface that we have. It is graphical. It is graphical user interface. This prime infrastructure provides some kind of graphical user interface, and it gives you like better insights of the network, the utilization, and all those things. It will show you things from one centralized point. So they had like this. They had this controller for the enterprise network known as the Epic EM, which was not very much popular. Then they started using prime infrastructure, which actually became very popular, and a lot of companies like are still using the prime infrastructure. Nowadays, they are no longer selling the prime infrastructure, prime infrastructure as well. Nowadays, for the enterprise network, they are offering a centralized controller, which will be responsible to manage your enterprise network from one centralized point, and that is known as the DNA center. Digital Network Architecture, DNA Center or DNAC, also known as nowadays the Catalyst Center. Catalyst Center is just another name of the DNS Center. So earlier it was known as the DNS Center. Nowadays it is known as the Catalyst Center. So Catalyst Center is now it is a centralized controller that we use nowadays. We purchase this controller from Cisco, we install it somewhere in our network, and then we make this controller reachable to the devices that we have in our SD, in our network. And then this DNS Center controller will be responsible to manage all these devices, configure these devices, create the network, create the fabric, monitoring, software upgrades. It will do everything from the centralized point. The very basic thing that DNS Center requires is the reachability. Very basic thing. The very basic thing that the DNS Center requires, this controller requires, is the reachability to the switches, reachability to the devices. The very basic thing that it requires is the reachability to the devices that it has to manage. Once the DNS Center becomes reachable, once this controller becomes reachable to the devices, DNS Center can do a lot of things on that device. Here, where is that? I guess I closed it. Wait. So DNS Center can actually do a lot of things. DNS Center, can do a lot of things from one centralized point. DNS Center can do a lot of things from one centralized point. The software that they created. This is a 3840 GB software that they have created, and we run this software on a server. And that server has to be powerful enough to handle all the things. So it is not a very cost-effective solution. So DNS Center, Cisco sells DNS Center as a hardware appliance. So you can go to Cisco, you can order DNS Center, they will give you a UCS server, they will give you a server. In that server, there will be an ISO image of the DNS Center, and you have to install it. So eventually, it's just a software. It is just a software that is running on some hardware and responsible to manage the entire campus network from one centralized point. Everything. So even we can leverage the things such as like, plug and play. So you can just, purchase a switch, take it out of the box, connect it into the network, and that's it. You don't have to do anything extra. You don't need to do any configuration. Everything we can pre-provision from the DNS center. That switch will automatically reach to the DNS center. DNS center will push all the configuration to the switch, whatever configurations are necessary. PNP, plug and play, for example. So, and similar to that, we have plenty of things. We can design our network from the DNS center. We can create the policies for our network from the DNS center. We can provision. Basically, we can check all the devices. We can configure all the devices. We can monitor. We can, troubleshoot. We can do plenty of things. We can integrate extra other services onto the devices. Like we can do plenty of things from this provision tab that we have within the GUI of the data center. And of course, don't forget about the monitoring. Here, go assurance, health. This is like the overall health of your network. How many number of devices are there? How many number of devices are healthy? This is the overall, how many wired clients are there? How many wireless clients are there? The detail about the different issues that are there. Different issues that are there. These are the issues that are reported in your network. Some P1 issues, P2 issues, such as like, the overall health of your network. This is called time travel. So I can see the health of the network in a certain time period. I can see the health of the network in a certain time period actually. So in this time period, how many routers were healthy, how many routers were up, how many routers are down, switches up, down, whatever. So I can check the overall health of the network right from this network tab. The client information I can check from here. All the clients that are connected in a wired or wireless fashion, I can check the information about the clients right from here. That I can do here. These are all the clients. I can click on the client. And I will get the complete information about that client right from the DNS center. So click on it and you will see client 360. Client 360 basically means complete information about that particular client. So scroll down and you can see like, how that client is getting onboarded. That client is connected via the SSID corp and it is connected to the this is connected to this AP and it is connected to this WLC. So I get a graphical view like how the client is connected, where the client is connected. All the events that have happened, like was the client able to get the IP from the DHCP or not? All the events and everything that has happened, I can click on that event and it will give me the details of it. Right? We can do the ping and trace right from here. From that client, I can run the ping. I am at the DNS center and I can ping from the client. I can ping like to some device. This ping is not from the DNS center. This ping is going to be from the device to the other device actually. So we can path trace. We can trace the path from the client to the internet, from the client to there. Client is saying that I'm not able to access the internet. I can check it if it is true or not. I don't need to log into the client. Then what is this? Then the information about the client, like what is this? Apple iPad, the name, the MAC address, IP4 address, IP6 address, status, VLAN number. I can get plenty of details right from. So this is called client 360. This is like the overall. This is the client dashboard. Client dashboard basically means where we get the information about the clients in very much detail. Then different applications that are running, different services such as AAA, such as DHCP, such as DNS. Are these services running properly or not? So like we have the service dashboard, network service dashboard, which basically gives you the idea about the different services that we are running in your network, such as AAA, such as DHCP, such as DNS. Different applications that we are running in the network. Like, this San Jose location is actually running business relevant application health is 54%. 72 GB of like, let's say, for example, users is there for the application. If you scroll down, it will show you like what applications are likely being used more as compared to the other applications. So we get like plenty of details in here. Medical records, Microsoft Teams, Office 365, WebEx, these are the applications that are consuming the traffic. And these are like top applications, I would say. You get that kind of view from the GUI of the DNS center. So basically monitoring, we can do plenty. Not only monitoring, I can go to the overall, like here, let's say an issue got reported. Let's say one issue got reported, like, some issue got reported, like switch unreachable, layer 2 loop symptoms, WLC unreachable. Some issues are reported, right? I can click on that issue. I can click. So if a layer 2 loop symptom is reported, what you will do as an administrator, you will have to find out where the loops are. So you will go on the switches, you will log into the switches, you will run the commands. So spanning tree, show this, show that, and you will see, okay, show MAC address table. You will run the commands by yourself to find out where the loops are. Okay. So it says that the DNS center has observed that this catalyst center has observed that there is a looping symptoms in this particular location. In this location, there is a switch, and onto that switch, a host is flapping in VLAN 1. Basically, host is flapping. Host flap observed in one VLAN. In some VLAN, host is flapping, like the MAC address is being learned on multiple interfaces again and again and again, which basically means that there is some loop in the network. Click on that. So click on that. It will give you the detail that the loop symptom is detected onto this switch, the role, time, location, potential root cause, MAC flapping. It will not only give you the insights of the issue, but we can also go for this root cause analysis, and I can run the machine reasoning. When I click on that, it will run some in the background. It will run some some algorithm. Basically, whatever we do, it will do it for us. So it will do it for us, like it will analyze all the things and it will understand. It will show you that actually there is a loop in the VLAN 31. Eventually, you will come to the same result. Like if you go to the location and you start checking, you will come to the same result. That there is a issue. There is a loop in VLAN 31. And why the loop is there in the VLAN 31? Why? Because actually VLAN 31 is not enabled. STP is not enabled for VLAN 31. STP, someone might have disabled the STP for the VLAN 31. So not only it is able to report the problem, but it is also able to give you the solution. It is going to predict. It is going to suggest you the action that if you enable the STP for VLAN 31, then those problems might go away. Right. So what it did, what you had to do, verify the port forwarding using this spanning tree protocol. So like not only it can give you the insights of the problem, but it can also suggest you the action that you can take to fix that problem. So same exact things you will do like manually as well, but it will take more and more time. Here we can just do a few clicks and it will give you the issue and it will give you the possible solution to that particular problem. So these kind of functions, these kind of things, like I can, for example, this WLC unreachable. So I can, what steps, what suggested actions are there? Verify all these things. So not only it can report the issue, but it can also suggest you. It can also suggest you the relevant actions that you can take. Actually, suggested actions. This is just one of the things that we can do from the DNS center. We can go to the. This is the monitor. This is the health and everything. So DNS center is basically just one controller that they have that you have to purchase, that they have to make reachable with the devices. And once the DNS center is reachable to the devices, DNS center will be able to manage all those devices from one centralized point. We can do the configurations, we can do the provisioning, we can do the monitoring. Oh, you want to do the software upgrade? Okay. You want to do the software upgrades into the devices. What you can do, you can go to the design, you can go to the image repository. Image repository basically means here we can upload the software image. So we have like 10 9300 series switches that we have to upgrade. So we can download the image, and what we can do here, we can import the image onto the DNS center. We will download the image from the Cisco website and we will just upload it here. Once we download and once we upload it on here, then after I will go to the inventory, I will go to the provision, I will go to the inventory, in the inventory, I will have my switches, I will have my routers, I will have my WLCs, I will have the access point, I will have all the devices. What device you want to upgrade? I want to upgrade the switch. So here is the switch that I want to upgrade. I will click on that action. There is that software upgrade you will see somewhere. Here, software image, and you can just click on the image update. So right from here, we can do the software upgrades onto that images as well. We don't need to log into the device, download the image on the device on per device basis. We don't have to do that. So a lot of things for which human intervention was required, a lot of things for which human interaction was required. Those things can now be done by the software. Software-defined approach to manage the campus area network is what we refer to as the SD-Access. SDA, software-defined access, is the software-defined approach. Software-defined approach to manage the campus area network is what we refer to as this. Or in other words, software-defined approach to manage the campus area network is referred to as the software-defined networking. Software-defined approach to manage the network is what we refer to as the software-defined networking. When it comes to the SDN, we have like SD-Access. SD-Access is the software-defined approach to manage the LAN of a campus area network. LAN of the campus area network. Like we have access layer switches, we have the distribution layer switches, we have the core layer switches, and we want to manage all those switches from one centralized point. For that, we can go for this SDA solution. And in the SDA solution, the controller that is required, the controller that will do all these tasks for us is known as the DNAC center, or also known as the catalyst center. And one more thing, DNAC center is actually Epic EM. Epic EM, which could not gain like a lot of popularity. When SD-WAN became very popular in the market, then Cisco redesigned, repurposed, restructured Epic EM. And DNAC Center has the exact same functionality as the Epic EM plus assurance. Assurance basically means monitoring. So it is the old controller. It is not a new controller. Actually, it is not a complete new controller. It is not a brand new controller. It is exactly same as the Epic EM. In the Epic EM, which they already had, they added some assurance functions, they added some monitoring functions, and they created a new controller called DNAC Center. And they started selling that controller to the companies. Catalyst Center or the DNAC Center is a centralized controller that we use to manage the campus local area network from one centralized location. LAN, access layer, distribution layer, and pool layer switches that we have if you want to manage those from one centralized point. For that, we are going to have this. No matter how many branches are there, we can have like hundreds of branches. In every branch, we can have like 2, 3, 4, 5, 6 switches. DNAC Center will be able to manage. DNAC Center is able to manage actually. DNAC Center is able to manage like n number of devices. Like currently, this DNAC Center that they have on the D cloud, it is currently managing 121 devices. It is managing like how many sites, and there are like a lot of sites and everything. 120 software image upgrades are there. DNA license devices are 105. We have like 62 sites. It is this current DNAC Center is this one DNAC Center solution. This one DNAC Center controller is managing 62 sites too. So it can manage multiple sites. It can manage multiple devices right from one centralized point. It is a centralized controller. It is a centralized controller that we can use to manage n number of locations, n number of devices from one single GUI, from one single dash. Epic EM is, DNAC Center is just repurposed, rebranded, restructured Epic EM along with the assurance function. It's the same thing. Software-defined approach to manage the campus local area network is what we refer to as the SD-Access. Software-defined approach to manage the campus wide area network is known as the SD-WAN. SD-WAN is the software-defined approach to manage the WAN edge devices. And now these WAN edge devices can be anywhere. These WAN edge devices can be there in the enterprise network. These WAN edge devices can be there in the data center network. Data center will also need to connect to the internet. Data center will also need to connect to the other locations and all. So software-defined approach to manage the WAN edge devices is what we refer to as the SD-WAN. Software-defined approach to manage the LAN is known as the SD-Access. Software-defined approach to manage the WAN edge devices is what we refer to as the SD-WAN. And the combination of both SD-WAN and SD-Access is going to be the software-defined networking. So software-defined approach to manage the LAN and WAN of the campus network or maybe the data center network is what we refer to as the software-defined network. Use of a software to manage the campus LAN WAN network is what we refer to as the software-defined network. And we have SD-WAN, and we have the SD-Access for the campus network, and we have the ACIE Epic for the data center network. So if you go for end-to-end SDN solution, we will require 3 things. We require SD-WAN for the WAN edge, we require SD-Access for the LAN of the campus network, and we require the ACIE Epic for the data center network. Total, a combination of these 3 things is what we refer to as the SDN, software-defined networking, offered by Cisco. These are the Cisco products. Cisco offers SD-WAN solution, Cisco offers SD-Access solution, and Cisco offers the ACIE data center ACIE Epic solution from the for the centralized management. Maybe someday later on, maybe someday they will have a centralized controller, centralized dashboard where like LAN, WAN, data center, everything can be managed from one point. Who knows? But currently there are three. These three are separate things. DNS Center is a different product. ACI Epic is a different thing, and SD-WAN, Viptela, like vManage, vSmart, these controllers are different. So we have different controllers for the SD-WAN. Currently, we have different controllers for the SD-Access. Currently, we have different controllers for the data center Epic. They all can talk to each other. They all can communicate to each other. Here, system settings. This is the DNS Center, and in the DNS Center, we can add. Where is that? vManage. Here, DNS Center can communicate with the vManage. What is a vManage? vManage is a SDN controller for the SD-WAN. It is for SD-WAN. So we have vManage controller for the SD-WAN. We have DNS Center for the SD-Access, and they both can communicate to each other via APIs, via application, programming interfaces. So that interaction is also. But currently there is no centralized dashboard to manage everything from one point. Like we have different controller for the SD-WAN, we have different controller for the SDA, and we have a different controller for the data center. They can, no doubt, they can interact to each other. That is fine with the help of the APIs. That is completely fine. But currently we do not have like a centralized dashboard for everything. So we will have to have, like, if you want to go for end-to-end SDN solution, you will have to go for three things: SD-WAN, SD-Access, and the data center, like ACI. Yes, go ahead.
How to integrate with the Cisco Epic ACI?
Here, like, we do not have, like, the only things that we can integrate are these ones. So we have like
vManage.
We have the vManage, we have Umbrella, we have like WebEx, we have like DNA Cloud. These are the things that this DNS Center can integrate with at the moment. So currently, you don't see like any integration with the Epic actually. So the only integration at the moment that they have made available is the vManage.
And the ICE services, we have to integrate to the ICE server, or itself having some basic services.
No. We have to integrate it. We have to integrate it with the ICE. This dashboard, this policy dashboard, it will open. It will work only when the ICE integration is done. So DNS Center is not the ICE server.
Instead of logging to the ICE, we will make the changes over here. The same will be replicated on there.
Exactly. But again, just one thing to clear, like, DNS Center cannot do like all the things that an ICE can do, right? The only thing the only thing that the DNS Center can do is this.
Relevant only.
Policy only. Only policy only.
Okay.
We cannot create, for example, in the ICE, we can create authentication, authorization rules. We can create the policies that we cannot do from the DNS Center. Not at least yet.
Okay, but the problem, whatever the changes we are going to do here, it will not get overlap with the existing one. Like for the ICE, I have so device profile, okay, and then the user profile somewhere. For the 3850 switches, Nexus switches, those have the different shell profile and all those things, right?
That you can have. That you can have. But these things will overlap. These policies that you have now. You can manage these policies either from the ICE or you can manage it from the DNS Center. You can't do it from both the places. Once you integrate the DNS Center with the ICE, a migration will happen between the two. The policies will be migrated from the ICE to the DNS Center, right? And then from DNS Center, we can create the policies, and those policies will be reflected onto the identity services engine. You will not have this dashboard, this UI in the ICE will go read only. You will not be able to do the configurations of the policies from the ICE then. The only thing that you will be able to configure is the authentication, authorization rules and those things.
Okay, understood.
So we get the option. It's not, so we get the option. Do you want to make the DNS Center as the front end from where we can do the policy configuration, or do you want to make the ICE, like, the front end for the configuring everything? So that is completely up to you. But if you use DNS Center for the policy UI, then ICE will be read only. If you use ICE, then you can manage everything from the ICE. DNS center will be read only. Both will not be allowed. Both will not be allowed. Which again, we will discuss in detail later on. So integration is possible. Like it is possible to integrate other external systems in the DNS center, such as umbrella integration is there, such as vManager integration is there, such as IPAM, IP address manager, IPAM servers we can integrate, Stealth Watch, some, a DNAC cloud such as WebEx, Thousand Eyes. We can integrate these things. ICE, Identity Service Engine, some generic AAA servers. We can integrate. We can do all kind of integrations actually. But again, you have to explore the. This is currently we are running like 2.3.5. Maybe in 2.3.7 they have some more integration things. Maybe in 2. Later on, maybe in the version 3, version 4, version 5, they might have more. It is all a matter of APIs. Like so, they might add like support of other external services in the DNS center later on. Who knows? But currently, these are things that are possible that we can do. Currently, these are the things that we can integrate with our DNS center. But that doesn't mean we can, for example, we can create a wireless profile from here. We can configure things about the wireless from here, such as we can configure the SSIDs and everything. But that does not mean that we will not require the WLC. We'll still require the WLC. We will do the things on the DNS center. DNS center will push these changes to the WLC, and it is eventually the WLC who will do all the things. We will create the policy on the DNS center. DNS center will push that policy onto the ICE, and eventually it will be the ICE that will enforce the policy in the. So it's more like it's just a matter of like UI. It's just a matter of the user interface from where you are going to. So you don't need to log into the if you want to create a policy, security policy. So you don't necessarily need to log into the ICE and the DNS center. Log into the DNS center and configure the policy right from there. Log into the DNS center, configure the switches right from there. Log into the DNS center, configure the SSID right from there. So you don't need to log into the WLC, you don't need to log into the ICE. We can do all the basic things from the DNS center itself. So a software responsible to manage the campus area network from one centralized point, providing us all these options that we get. It is inside the, as it is like the controller that is used in the SDA solution, software-defined access solution. We can, these are four major workflow. We have design workflow, we have policy workflow, we have provision workflow, and then we have assurance workflow. And let's say you don't know about anything. Let's say you don't even know what is the DNS center and all that. No issues. Go to the workflow. Let's say you are completely new to the DNS center and you don't know like anything about the DNS center. And someone asks you what we have to do. We have to discover a new device in the DNS center. And I don't know how DNS center, how can I use the DNS center to discover a new device? I don't know. For our help, what they have done, they have created these workflows. So scroll down, and you see, do you see anywhere like it says discover the devices? There is going to be like one, you have this discover device. So click on this. It's more like a guided wizard. Like, it's more like a wizard. Okay, next. So, okay, device controllability is enabled. Okay, click on the next button. So, how you are going to discover the device? Are you going to discover the device based on the CDP, or do you know the IP address of that device? If you know the IP address of that device, then just provide the IP address. Or if you want to discover the device based on the CDP, then use the CDP. So it will guide you. It will guide you through a wizard that you can use to discover the device. So even if you are like not very much familiar with the same, you can discover the things right from here. Right. So we do have like plenty of workflows. Here, and they are adding these continuous workflows. These are they are adding like they are continuous. Let's say you don't know how to set up the site-to-site VPN. Let's say you're not from the security background and you don't know how to set up the site-to-site VPN. No problem. Just click on the site-to-site VPN workflow. Click on the let's go. Just provide the detail from between which two sites you want to create the site-to-site VPN. Just provide the information like in between what sites you want to create the site-to-site VPN. Like we have one router, we have another router, and we want to create a site-to-site VPN between the two routers. So just provide the information and just click on the next button. It is more like a guided wizard that you can go through to achieve, like to configure like variety of things onto the devices. Yes. So this is again the DNS. The SD-Access is just one of the part. SDA, software-defined access, is just one of the part of the DNS center. Here, SDA is just one of the part of the DNS center. Apart from that, we have other plenty of things as well. We have like wireless, we have like policies, we have like IoT integration, we have like the VManage integration, we have the ICE integration, we have like plenty of things. We have different tools. So SDA is one of the part that SDA is something that is offered within the DNS Center graphical user interface. SDA is more like a concept that says that we can manage all the campus area network from the centralized point. SDA is software-defined access. It is an approach to manage the campus LAN devices from one centralized point. And to manage that campus LAN devices from one centralized point, the controller that we use is called the DNS Center. DNS Center is a centralized controller that offers us the SDA functionality, actually. So yeah, from that point of view, that is correct. Right. So this is just this is just the demo. This is like this is just from the demo point of view, but this is like all the functions, all the things that we get. You can explore the UI of the DNS Center. We'll discuss more about it, but you can discover the user interface of the DNS Center, and you can get more details like what things that the DNS Center can do, which we'll explore throughout the content. But for meanwhile, like you can go to the dcloud DNS Center, and you can explore what things the DNS Center can do by yourself. Later on, when we proceed through our content, we will go through like each and every option one by one. I'm not saying it is not a DNS Center class, by the way. It's an SDA class. So we will not explore each and every option of the DNS Center. No. Let's be very fair. We will explore the things that are relevant to our content, first of all. Then if some time is left, then I will talk about the rest of it. Right. So this is just the introduction. This is like what is as software-defined networking, why we use software-defined networking and all. And now we can these things we have talked about. Tomorrow, from the PPT point of view, we will talk about that as well. But these things we have covered. I will brief you one more time, like why we need software-defined networking and all. And then we will continue with the what is this underlay, what is this overlay, what devices we need, what devices are compatible, and all those things. We will talk about how to design the SDA network, how to deploy the DNS Center, deployment, installation of the DNS Center, everything we'll talk about from the scratch. So after 2024 classes, you will have like enough understanding that you can manage the campus area network with the help of the DNS Center. Right. So this is just the introduction. We will continue from here. In our next class, we will talk about the technicals of the SDA, software-defined access. All right. So Cisco Software-Defined Access, SDA. So software-defined approach to manage the LAN network is what we refer to as the software-defined access. So why do we need software-defined networking? Already we discussed this thing in last day, but let me just revise it. So it says that there are many challenges in today's network in managing the network because of manual configuration. So if we have to deploy a device in a network, we will have to configure that device manually. If we have to deploy like n number of devices, all those n number of devices, we have to do the configurations manually. So manual configurations are going to be there. Configuring devices manually one by one is going to consume like a lot of time, resources, and manual configurations are slow, error prone, and they are proving to be ineffective because the rate at which the changes are happening in the network, it is much more greater than the rate at which humans like we can do the changes onto the devices. So manual configurations are slow, error prone, and they are proving to be ineffective in a modern day network. We have different tools, different companies, different vendors, they use different tools to do the configurations on the devices. So as a network engineer, you might need to work on a variety of tools, and using those tools, you will be able to understand the configuration part. Using those tools, you can do the configurations on some specific vendor devices. But fragmented tool offering basically means like different vendor offer different tools. So you have to be aware of those tools if you want to do the configurations in an automated fashion. With the growth of users, different devices types coming in. Earlier, what was happening? Earlier, humans were the only users of the network. Earlier, humans were the only users of the network. Like we were the user of the network. We were using like the applications. We were using the network resources and all. But nowadays, humans are not the only users of the network. Like apart from the humans, we also have like these smart devices. We have like concept of IoT and all. So nowadays, like devices like like sensors, like IoT devices, CCTV cameras, pagers, speakers. These devices are also users of the network. Like humans were the only users of the network earlier days, but nowadays, if we talk about that, nowadays, like we have different types of devices that we use in our network, different types of IoT devices, such as like cameras, CCTV cameras, like speakers, pagers. We might use the concept of like smart home appliances, and also those smart devices are also nowadays users of the network. So it says like the growth of the users. That means there are like a lot of users that are accessing the network resources, and different device types are coming into the network. That means like not only but we have nowadays different types of devices that we are going to see in our network. Configuring the user credentials and maintaining consistent policy across the network is going to be a challenging task. We also have like the challenges regarding the policy. Continuing from the last class, we also have the challenges regarding the policy. Policy basically means like, let's say the same thing, like HR department cannot communicate with the finance department. This is our policy. Finance department cannot communicate with the admin department. This is our, let's say, access policy. This is the policy that we have in our infrastructure, that HR department cannot communicate with the finance department cannot communicate with the admin department. Only the admin users, are supposed to get the access of the switches. Like only the admin users are supposed to get the remote access, like telnet SSH of the switches. This is a policy that. Now, not only we have to enforce this policy in a wired network, but we also need to enforce this policy in a wireless network. What do I mean? I mean that in a modern day network, we not only have the wired users, but we also have the wireless users. So if a user is connecting itself with the network using the wire, then also the same policy should be applied. And if the user is connecting itself via some wireless technology, such as Wi-Fi, then also the same policy should be applied. So we have to create the policies for the wired user. We have to create the policies for the wireless users. We need to create like different policies. We need to create like multiple policies. One like maybe for wired user, maybe for wireless user, maybe for IoT devices, maybe for like HR, finance, admin departments. And we have to make sure that those policies get applied for both like wired users and the wireless users. So configuring the user credentials, maintaining the consistent policy across the network for the both wired and wireless user it is getting like more and more complex. Number of users are growing significantly, number of different types of users. Different types of user basically means like apart from the humans, the IoT devices, CCTV cameras, pagers, speakers, smart home appliances. These are like nowadays like these ACs, projectors, these devices we can connect to the network, and we can manage those devices from the network. So humans are not the only users of the network nowadays. So we nowadays have different types of devices. Now we have to maybe configure a policy that IoT devices should not be able to communicate with the HR department, or IoT devices that we have, they should not be able to have the access of the finance department, and so on. So that thing we also have to make sure. In short, basically the rate at which the changes are happening, they exceed the human scale. The rate at which changes are happening, they exceed the human scale, which means that the rate at which the changes are happening, humans like we cannot do the change at that particular rate. If we have to do a change in a production environment, like if let's say for example some change needs to be done in the production environment, we might need to get the authorization from like higher like authorities. Like we might need to send some emails, like get some confirmation from the higher like management, and then we can do the changes, and also it takes like time. So the rate at which the changes are happening, they exceed like human scale. So basically, if I summarize all these things, in a modern day network, we have two major challenges. We have network operation related challenges, and then we have security related challenges. Let's not even talk about the cloud integration. Let's not even talk about like the IoT. Let's not even talk about the deployment. Let's not even talk about the other types of challenges that you might face in your infrastructure. Networks cannot respond quickly to evolving business needs if the changes needs to be done manually. Such modifications take a long time and they are prone to errors. So if let's say, for example, a customer says that now we need to change this particular thing, you might need to get the authorization from the higher authorities, and then you will only be able to implement the changes in the production. So again, same thing. The rate at which the changes are happening, they exceed the human scale. So since these were all these challenges, they thought like, why don't we use some software defined? Why don't we use like some software to overcome all these challenges? Why don't like humans, like why don't we don't configure the changes on all the devices manually? Why don't we use some softwares to do these things for us? Why don't we create some software and we will run that software on some kind of hardware, and that hardware is what we are going to refer to as the controller. So Why don't we create some softwares, and those softwares will be responsible to do all the configuration, provisioning, monitoring, troubleshooting, and everything for us from one centralized point. And that is where they introduce this software-defined networking in the market. So again, software-defined networking is software-defined approach. Software-defined approach to manage the network is what we refer to as the software-defined networking. Programming and everything is not we can also introduce like programming here. Like we can create the Python scripts, we can create the scripts, we can run the scripts, and those scripts are going to do the changes for us. It will make a network much more manageable. But still, like if you just use a controller and navigate to the GUI, graphical user interface, and do the changes, then also that is the same. So completely up to you. Are you going to navigate the controller using the GUI, or if you are good with the concept of programming, if you are good with like APIs, scripting and all, then you can also use the APIs. You can also use the scripting to do all kind of changes with the help of some tools, some automation tools. So that is also one thing. Both the options are available. Both like SD-WAN controller and SDA controller, like vManage and the DNS center, both are programmable. That both can interact with the third-party automation tools using APIs. So if you don't want to, if maybe you don't want to use the GUI, if you are good with the scripting, if you are good with the APIs, then you can use the automation tools to interact with the DNS center, to interact with the vManage using the API, which we will cover at the very end of our classes. At the very end, I will show you how those API calls are made, but I will not use any automation software. I will just use the web browser. From the web browser itself, I will show you how to make like variety of API calls and do the same things via the API, not with the GUI. So for that, of course, you will require some programming calls for the same. Effective network segmentation can be exceptionally difficult to achieve in a complex network with a variety of users, devices requiring different access privileges. So there are different types of users. Some users are in our company for like last 1 year, some users are for last 3 years, some are for last 5 years, and we want to have different privilege levels for the same. The user that has just joined the company last like 6 months, I am not going to give them privilege level like 15. I'm going to give them just basic privilege level 1. They can do some verification. They can some do like ping pong. They can do all those things. They will mostly do the monitoring. They will not get the hands on the configuration part. The user that is in our network for that experienced user, for example, like we have some like 2-3 years experienced candidate, and I will of course give him more access. Like I will give him privilege level like maybe 10. So that user will get like some monitoring level access. That user will also have some configuration level of access as well. And the user that is there for a very long time, that has too much experience, that has way much experience, I might give him the full configuration access as well. Basically, we have different types of users of the network. Like we have like experienced users of the network. We are talking about from the company point of view. We have experienced user of the network. We have an experienced user of the network. Like we might not want to give like full access to all the candidates that we have in our. I am not going to give like complete read and write access of my switch to one particular user that has just joined the company in last 3 days. So I'm going to have some privilege level. I'm going to define some privilege, and based on the privilege, I'm going to assign the role to that particular user. Also, like from the end user point of view, the end user who is trying to access the network resources, that end user might also not have complete access of the devices, of course. So we have different types of user in our network. Different users, they require different privileges. We have different devices in the network, such as IoT, such as cameras, such as like these access points, these WLCs. Different devices, they also require different privileges. So how we are going to do effective segmentation between our corporate devices, how we are going to do our effective segmentation between the IoT devices, how we are going to do the effective segmentation with the between the guest devices. So we have some corporate user, we have some IoT devices, and we have some guest users. In the corporate, we have different departments such as like HR, such as like finance, such as like admin, and then IoT we have like some CCTV cameras. Then we have some maybe some speakers, some sensors are there basically. That can be there. Some sensors we have deployed maybe we have some like CCTV cameras, we have deployed some sensors, some temperature sensors, and those kind of things we have deployed in our data center to monitor the temperature of the data center environment, so that we can power on, power off the devices, cooling accordingly. We can manage the cooling accordingly. Maybe that kind of sensor we have. And the guest user who is just coming in our infrastructure, he is accessing some like internet and all, and then he is just going away. These are not our company employees. These are just the guest user. So how we are going to have the effective segmentation between the corporate user, how we are going to have the differentiation between the IoT and guest and the corporate, In the corporate also, we have HR, finance, admin, and how we are going to have the policy that HR cannot communicate with the finance cannot communicate with the admin, HR and admin can communicate. We can have different types of policies. So how we are going to do all that kind of thing. So as basically the network growth happens, doing the segmentation in the network based on the ACL, based on the VLAN is going to be much more complex. So like corporate users, they belong to 10.1.1 subnet, okay? 10.1 subnet. IoT devices, they belong to 10.2 subnet. Then guest devices, they belong to 10.3 subnet. We have configured different subnets for different devices, like corporate users are in one subnet, IoT are in another subnet, guest are in another subnet. And the corporate users, we have HR, finance department, we have VLAN 10, we have VLAN 20, and we have VLAN 30. We can have the segmentation based on the VLAN. We can have the segmentation based on the access list. We can control who can communicate with what device not. Like we can do all that thing with the help of the ACL. We can do all that thing with the help of the VLAN, but that's not going to be very effective. If we have like too many devices to manage, doing the segmentation based on the access list, doing the segmentation based on the VLAN is not going to be very effective solution. Traditional IP-based methods with firewall, VLAN, ACLs do not scale, and they are not efficient in responding to the real-time needs. If you have n number of devices, if you have like n number of branches, let's say you have 10, 15 branches all across the world, then we have 2 data centers and 2 headquarters. And we have to carefully enforce the security everywhere. Like we have to enforce the security everywhere. We have to enforce the security in all those 15 branches. We have to enforce the security in all the data centers, and we have to enforce the security in all the headquarters. So what you are going to do? Are you going to install a firewall device in every branch? We can do that. We can deploy a firewall device in every branch. But that is going to improve the security 100%. But that is also going to make network more complex, because now you have to manage all those firewalls on all these branches, headquarters, data centers one by one. Are you going to send all the traffic to the data center, then from data center to the internet? That can also be one approach. That I'm not going to install like a firewall, a security plans in each and every branch. I'm going to send all my traffic to the data center. In my data center, we have the firewalls, we have the IPS, IDS, we have the devices, and the traffic will pass via that particular data center devices towards the internet. But what about the user experience? What about the latency? So if you like redirect all the traffic via the data center towards the internet, then you are also introducing some latency in those cloud applications like Office 365, CRM applications, and all those. So you can add a security appliance in all the branches. It will improve the security, but it will also add on additional costing. It will also make network much more complex to manage, because now you also have to manage a firewall of every branch. Apart from routers, switches, access points, WLCs, now you also have to manage firewalls, like 10 firewalls you have to manage. But at least the security is good there. So you can redirect all the traffic via the data center, so that you don't need to you're not required to manage, you're not required to install a security appliance on each and every branch. But again, in that case, like if you are redirecting all the traffic via the data center, then what about the user experience? What about the latency delay that you will face in accessing those applications that maybe are hosted on the cloud? So that is also going to be one challenge. Overall, not repeating everything again and again, the bottom line is that the networks of today, they do not address today's business needs. Overall, the point is like the way modern day network has evolved, the traditional approach to manage the network is not going to like scale very well. It is not going to address the issues very well, actually. As per this is like, this is a very old infographic, but as per this infographic, like it says that 95% of the network challenges, 95% of network changes are done manually. 75% of like operational expenses are spent on the changes and troubleshooting. Companies spent approximately 75% of the operational expenses on the changes and troubleshooting. 70% of the policy violations happen during the human errors. Like you ask the humans not to tell the password to everyone, but that is one challenge that you might. A ratio of the operational expenses to the capital expenses is 3:1. Like we are spending more in troubleshooting, we are spending more in managing the network than we are doing in the deploying the network. Actually. So the ratio in which the operational expenses and the capital expenses, the ratio is basically, it was like 3:2. It is a very old infographic, but it was like addressing the challenges that we were having in the network where we are not using any software-defined approach to manage the. So to address these challenges, they decided to use like, why don't we introduce some software-defined approach to manage the network, where engineer will configure its intent and the software will configure the network onto the devices. I will configure my intent. Intent basically means what do I want to do? What I actually want to achieve. Okay, I want to achieve that the HR department should not be able to communicate with the finance department. This is my intent. This is what I want to configure. So I will configure my intent. I will tell my controller, I will tell the controller my intent, and the controller is going to configure that. Controller is going to take the intent, it is going to convert it into the configuration, and it is going to push the configuration onto the devices to make this particular thing happen. Network engineer will configure the intent, and the software will automatically configure the devices based on the intent. We will go on to the controller, and on the controller we are going to define what do we want to do, and the controller is going to configure the devices for us. If we have like n number of devices, controller can push the configuration on all those n number of devices at once. So we don't have to log into all those n number of devices one by one and do the configuration changes one by one again and again. We just need to define our intent. What do we want to do? What exactly do you want to create some segmentation based on the VLAN? Like you want to create like a corporate IoT and a guest. You want to have the segmentation between the corporate IoT and guest users? No problem. Just go to your controller and create a corporate VRF. Tell the controller to create a corporate VRF. Tell the controller to create IoT VRF. Tell the controller to create the guest VRF, and the controller is going to push these VRF configuration on all the devices automatically. We don't need to go on all these n number of devices and configure the VRF configuration manually. VLAN manually. I don't need to do that. So in software-defined networking, we directly do not interact with the devices. We interact with the controller. Controller interacts with the devices. Earlier, what was happening, like these were the n number of devices, and we were interacting as a human. We were interacting as a network engineer. We were interacting with all those n number of devices one by one manually. But now there is a controller. There is a controller. So we are going to interact with that controller, and that controller is going to interact with the n number of devices for us on the behalf of us. The controller we are going to configure our intent on the controller, and controller is going to push that intent on all those n number of devices. And since it is a software, basically now, earlier humans were communicating with the software. Now software is communicating with the software. Like a piece of software is communicating with a piece of software. Like controller is communicating with the iOS. That here is what you have to configure, here is what you have to configure, here is what you have to configure. Earlier we were logging to the devices using the PuTTY, secure CRT, we were doing the SSH, and we were doing the configuration manually. So earlier we were interacting with the devices directly, but nowadays we interact with the controller. On the controller, we interact with the controller using the GUI, and we provide our intent, and the controller configures the intent on the devices for us, actually. Software-defined approach. Software-defined approach to manage the campus network is what we refer to as the campus network, data center network, maybe. So that is what we refer to as the software-defined network. Software-defined approach to manage the network is what we refer to as the software-defined networking. And here what we do, we use a software which is installed in a hardware, and that hardware is what we refer to as the controller. In short, we will use a controller to push the configuration changes, to do the monitoring, to do the provisioning, to do basically everything, software upgrades and all, to do everything on the devices. We will just tell the controller that we had to do the software upgrades on these n number of devices. Controller will push the software code on those devices, and it will do the software upgrade for us on those n number of devices. Different vendors, they offer different SDN solution. We have different vendors. Those different vendors, they offer different SDN solution. Different vendors, they offer like different SDN solution. Cisco offers like three. Cisco used to offer, I would say, three main like SDN solutions. One was like Open Daylight controller. There was an Open Daylight controller which was based on Open SDN model. So earlier when they decided to use that we should use some software to manage our network from a centralized point. So different vendors, they had a meeting. In that meeting, they started working on an open standard solution for a controller. They did create it like open flow, off flex and those things. They created an open standard controller. that everyone can use. And that controller was supposed to manage all the vendor devices like from one centralized point. So, okay, that's fine. When the controller was made, Cisco acquired it, and Cisco created some changes in that. Cisco made some product like some specific changes in that, and they launched their own commercial version of that particular controller. So Open Daylight controller was that. Open Daylight controller was that controller which Cisco basically built in the very beginning. It was based on the OpenSDN solution. They did some vendor specific. They provided some vendor specific things in that controller, and they released the commercial version. Obsolete, like no need to worry about that. It was an OpenSDN controller, Cisco OpenSDN controller OSC. It is now obsolete. It works based on the OpenSDN model. So Cisco no longer says like OpenSDN controller. Then we have like prime infrastructure. We have PI. Prime infrastructure. Prime infrastructure is also one controller that we use in our enterprise network to manage the devices, to get better details of our infrastructure from one centralized point. But that also will soon go end of sale. It has already gone end of sale. It will soon go end of life, end of support. So that is also, it is going to go obsolete by 2026, 28, whatever it was. So it will also go obsolete sooner or later. For the data center network, we have ACI, Cisco Application Centric Infrastructure, ACI for the data center network, where the controller that we use is referred to as the EPIC, Application Policy Infrastructure Controller. EPIC is the name of the controller that we use in a data center infrastructure, and the data center infrastructure is referred to as the ACI data center. ACI data center basically means like the data centers are built around certain applications that they serve, hence the name Application Centric Infrastructure. Data center network is application centric. They are built around the application that they basically serve. Then they had like enterprise module for the same EPIC-EM. EPIC-EM was for the enterprise network, could not gain a lot of popularity, so it also has gone like obsolete. So these were like some I would say in past these like controllers were being used. Modern day network, in a modern day network, if you want to achieve the end-to-end SDN solution based on Cisco only, so Cisco offers like SD-WAN for next-gen wide area network. Cisco offers SD-Access for campus area network, and Cisco offers like ACI EPIC for the data center. So if you want to have like end-to-end SDN solution, three things you have to go. If you want to have like end-to-end SDN network in your campus, in your data center, then you have to go with this solution. This is the overall picture of the end-to-end SDN solution offered by Cisco. Other vendors might also offer the same, but Cisco offers like these three main solutions for your enterprise network, for your data center network, and for the WAN edge devices. WAN edge devices can be there in the campus network. WAN edge devices can be there in the data center network. So these WAN edge devices can be managed centrally with the help of the SD-WAN solution. So SD-WAN is not only for campus or for the data center. It is to manage like all the WAN edge devices from the centralized point. Those WAN edge devices can be there in the branches. Those WAN edge devices can be there in the data center. Those WAN edge devices can be there in the headquarters, whatever. So that like SD-WAN. SD-WAN is WAN technology. Right? WAN use some software-defined WAN to connect your headquarters, data center, branches all together. So that is SD-WAN. And SD-Access is for the LAN side of the campus network. So we have like here, we have some our campus network built, and we want to manage this campus network from one centralized point. For that, like we have the SD-Access, and inside the data center, we have the ACI data center, where we use the controller called EPIC, Application Policy Infrastructure Controller, where we define like, EPG, endpoint group, policies, and all those things we configure. We basically, again, that is the data center engineers, they take the requirements from the clients, they take the requirements from the customer, and they define that requirement, they define that intent on the EPIC, and EPIC is responsible to configure all the data center switches devices that we have. Someday when you cover the data center, you will know about it. Our focus currently is only on this. This is what we will focus on. Later on, we will focus on this one. This we will of course not cover. This is part of the data center infrastructure. So SDA is the software-defined approach to manage the campus LAN. SD-WAN is the software-defined approach to manage the WAN edge devices. And ACI EPIC is the software-defined approach to manage the data center infrastructure. Altogether, if you go for all these three solutions, you will get end-to-end SDN solution for your campus, for your data center, and for your WAN. Any doubts so far? Any questions? Let me know. Any doubts? Let me know. Again, same thing that we covered in the last class, same thing we are revising here. Nothing extra, nothing else, just from the PPT point of view. No differences at all.
Okay, I'm audible. Shrikant here.
Yeah, Srikant, yeah.
Are we integrate all those three controller in a same on a same place?
No, not
We
yet.
have
You
to
can not yet.
we have to
You
open
can
the three
integrate.
separate GUI, is it?
You will have 3 separate GUIs. At the moment, you can integrate like DNS Center and the Viptela, like that SD-WAN, but directly you cannot integrate like the ACI Epic directly with the DNS Center. Not at least yet.
Okay.
Right. So we will have one GUI, like we will for the SDA, the controller that is used is called DNS Center, also known as the Catalyst Center nowadays. So we will have one GUI for this controller. Then for the Epic, of course, we will have one GUI for our Epic, and then we will have one GUI for our vManage, which is also known as the manager nowadays. Catalyst SD-WAN, Cisco Catalyst SD-WAN manager. So manager, like we will have one GUI for the same. Then if you have like what is this? APs. So you are going to manage these access points from the wireless LAN controller. So we'll have the one GUI for the WLC. Then of course you are going to have some security based on what identity services engine. So we'll have one GUI for that one as well. Integration is possible. We can integrate ICE with the DNS Center. We can integrate WLC with the DNS Center. We can integrate APs and all. We can integrate the vManage solution in the DNS Center. We can do that. But you will notice that even if you do that, you will still need to interact with the GUI, graphical user interface of these controllers. Some like one by one, you have to interact with like these. You will notice that in some places you will have to like interact with the controllers like you will have.
ACI perspective, there is the Nexus dashboard.
That
Monitoring and configuration.
There's a Nexus dashboard that we can manage. That Nexus dashboard is also available on the D Cloud for the demo purpose. You can also check that out. But at the moment, not complete integration. They might be planning to do that like in a longer term. Like so, since earlier, like for example, vManage integration was not there. If you go to the older version of the DNS Center, you will see that the vManage was not there. We could not integrate like the vManage with the DNS Center. But nowadays we can. So maybe later on, nowadays we can integrate like Stealth Watch, Umbrella. We can integrate like the what is this IPAM. We can integrate like that WebEx. We can integrate like Thousand Eyes. We can integrate like these external solutions nowadays. So maybe sooner or later, like they might have some common GUI for the same. But again, even if you do that, when we go through our classes later on, you will notice that okay, we have integrated the WLC with the DNS Center. We have integrated the ICE to the DNS Center. But you will still notice that when we have to configure the authentication and authorization rules, I will still need to go to the ICE. Like DNS Center will not be able to do. Like in the DNS Center GUI, we only and only can do the segmentation. We cannot create the policies. We cannot create the authentication authorization rules. So I would still say that you still need to interact with all the GUIs one by one. You need to interact with all the controllers like one by one. vManage, then we have the DNS Center, then we have the Epic, then we have the WLC, then we have the ICE. We still have to interact with all these devices like one by one. We can do plenty of things from the DNS Center, but not all of the things. That's what I'm saying. So you can still do like a lot of things from the DNS Center about the WLC, about the ICE, about the vManage, but not all the things. Like we cannot do like it. Now we will specifically focus on the SDA. Now this is the basic introduction is done now. Now we will specifically focus on the SDA solution. Now we'll specifically focus what is the SDA, what are the components of the SDA, and how can we build our software-defined infrastructure in our campus area network. So Cisco SDA solution. Cisco SDA solution within the Cisco DNA, Cisco Digital Network Architecture, aka like also known as the DNS Center. So Cisco like DNS Center, DNA Center. DNS Center is it is a hardware appliance that Cisco sells. You have to purchase this hardware appliance. In that hardware appliance, there will be an ISO image of the DNS Center. Like there will be an ISO image that we have to install. Once you install that, just like you install the Windows, just like you install the operating system onto your laptop. Similarly, you have to install the DNS Center on that hardware box, and then you are going to like connect that hardware box into your infrastructure, and then you are going to manage the things from the DNS Center. So DNS Center is more like a hardware that you can download and install in a hardware in some like server. Like we have to download it is like DNS Center is a software basically that we can download from the Cisco website, but we have to install that software somewhere. So either you can purchase the hardware from Cisco, Or if you have a good resource server, then you can install it in your like own server. Later on, when we see that what are the hardware requirements to install the DNS center, you will get the idea. What server we will require? You will require a server that has at least like 44 ports, a server that at least has 4 to 6 TB of storage, a server that at least has 200, 400 GB RAM. So you will require a big server, and then on that server, you are going to install the DNS Center software image, and then this is what we are going to know as the controller. So either you download the software image from Cisco, if you have the proper service contract, then you can. If you have purchased the DNS and if you have purchased the SDA solution from Cisco, you are authorized to download that image from the Cisco website. Then you can install it in a server. If you have a good server, if you have a well-resourced server, then you can install it. Otherwise, you can just purchase it from Cisco itself. You purchase the hardware from Cisco. You ask them that I want to purchase the DNS Center solution. They will give you a hardware. That hardware will already come with the ISO image, and you just have to install that ISO image onto that particular hardware. And that is what we are going to know as the controller. And inside that controller, inside that DNS Center, there will be something called SDA. So Cisco SDA is a solution within DNS Center. Like DNS Center offers much more things as just the SDA. DNS Center also offers wireless integration. DNS Center also offers like our ICE integration, umbrella, and all these things. Like we can do monitoring, we can do troubleshooting, we can do a lot of things from the DNS Center. But the important thing that we can do from the DNS Center is to configure our network devices from one centralized point, provision the devices from one centralized point. So Cisco SDA, software-defined access, is a solution within the Cisco DNS Center, also called DNAC, also known as the Catalyst Center, which is built on intent-based networking. It provides visibility-based, automated, end-to-end segmentation to separate users, devices, and application traffic without redesigning the underlying physical infrastructure. It says that if you already have built your campus area network, you don't need to redesign. Like you already have access layer, you already have distribution layer, you already have core layer. It's all good. It's all fine. You do not need to redesign the network. You don't need to like reconfigure the network. Let the network running as it is. Like we don't need to do any like recabling. Like we don't need to do any extra cabling and everything. Let the configurations run as it is. And because when we use the DNS Center to configure our network, we will notice that we will not require to restructure, will not require to redesign our physical underlying infrastructure. Why? Because the SDA solution works based on a concept of overlay. SDA solution works on a concept called overlay. Just like, SD-WAN also works on a concept of overlay. SDA, software-defined access, also works on a concept of the overlay. What is an overlay? So let's say here is your internet service provider. Here is one of your branch, second branch, third branch. And here is, let's say, for example, your 2 data centers. And these data centers are, let's say, interconnected to each other. This is, let's say, for example, how we have the connectivity in between our 3 branches and the data center network that we have. So this, we have configured an IP address, IP address, IP address, IP address, IP address, default route, default route, default route, default route. We have configured the default route. So reachability is there. Reachability is there in between all the devices. So this is what we refer to as the underlay. This infrastructure is what we are going to refer to as the underlay. Underlay is the underlying physical infrastructure. The underlying physical infrastructure is what we refer to as the underlay. And this underlying physical infrastructure is responsible to provide the services to a logical network that is built on the top of the underlay. Now here in this design, in this network, we are going to build some GRE tunnels. In this design, we are going to build some DM VPN, some IPsec tunnels maybe. So what we are going to do here, we are going to build in this infrastructure, we are going to build some like, some IPsec tunnels. We are going to build maybe some, DM VPN tunnels maybe. So this logical network that is built, on the top of this logical network that is built on the top of underlay is what we refer to as the overlay. Overlay is the logical network that is built on the top of the underlay. Overlay is the network that is built on the top of the underlay. Underlay provides the services to the overlay. What services? For example, reachability. The responsibility of the underlay is to provide the reachability. The responsibility of the underlying infrastructure, the responsibility of the underlay network is to provide the reachability, between these IP addresses so that a logical network can be built on top of that underlying infrastructure. It's like a bridge between like two locations. You can take that bridge to send the traffic like from one point to other point. But that bridge is of course built on the top of some underlying infrastructure. If you do not have like pillars, if you do not have like the physical infrastructure, then your logical network cannot be built. Same exact concept we have here. Same exact concept we have here in our SDA as well. They say that you can have access layer devices. You can have the distribution layer devices. You can have the core layer devices. You do not need to restructure the network. You do not need to restructure the network. You do not need to restructure the network. This is access layer switch 1, access layer switch 2, access layer switch 3, distribution switch 1, distribution switch 2, port switch 1, port switch 2. We have like the this kind of physical infrastructure you already have built. Then we have some routers here. We have some routers here. It is connected to like that. It is connected to the internet. It is connected to the headquarter, data center, branches, and all. So we have this kind of design. Maybe they say that you do not need to redesign. You do not need to restructure your physical infrastructure. Let this physical infrastructure remain as it is. Because when we talk about the software-defined access, SDA works on the principles of the overlay. So this physical infrastructure will now be treated, this physical infra will now be treated as the underlay. And on the top of that, a logical network will be built. That logical network is what we are going to refer to as the overlay. A logical network will be built on the top of this underlying infrastructure, and that logical network is what we are going to refer to as the overlay network. And whenever you hear the word overlay, just think of tunnels. Like overlay, every time you hear the word overlay, just think that there are some tunnels and the traffic is being passed from the tunnels. That's it. How those tunnels will be built, who will build those tunnels, we'll talk all about that later on. But whenever you hear the word like overlay, you will have to deal with the tunnels. Like if you talk about the DM VPN, GRE, IPsec, we have IPsec tunnel, we have DM VPN tunnel, we have GRE tunnel. So similar, whenever you hear the word like overlay, think of tunnels. Think that there will be a logical connection, there will be a logical reachability, there will be a tunnel from this device to this device, and via that tunnel, the traffic is going to pass from device to device. The physical infrastructure will just be responsible to provide the reachability, nothing else. We do not need to restructure our entire infrastructure. We will not need to restructure our entire infrastructure. The entire infrastructure, the underlying infrastructure will remain as it is, and we are going to build a logical network on the top of that, and that logical network that we will build on the top of that is referred to as the overlay, and the traffic will pass via the overlay network from one device to the other device without requiring to redesign or restructure our physical. Now, how these will be built, how these tunnels and all, it will be discussed throughout the content. How this overlay network, how the SDA network is built, that is discussed throughout the. Now, Cisco SDA also, Cisco Software-Defined Access automates the user access policies. So organizations can make sure that the right policies are established for any user or device or with any application across the network. No matter if the user is connected via the LAN or if it is connected via the wireless LAN. It says that we can go to the DNS center, we can configure the policies from the DNS center, and those policies will be applied. Unified policy. Unified policy basically means a common policy for wired and wireless network. So we don't need to go on the WLC. We don't need to go on like the different appliances and configure the policies one by one. We will just stick on the DNS center. We'll just stick to the DNS center. In the DNS center, we will go to the policy tab, policy workflow, and from the policy workflow, I'm going to create the policy that this user can access this application. This user cannot access, for example, this application. This user can communicate with this user. This user cannot communicate with this user. We are going to do all that. And that policy will remain common. That policy will remain same for both wired and wireless user. So as a network engineer, we don't need to worry about applying two different policies for two different types of user. Just one unified policy for both LAN and WAN. So no matter if the user connects itself via the wire or if the user connects itself via wireless, it just does not matter. The way wireless works in the SDA is different. The way wireless works in the software-defined access is a little bit different. It's not exactly the same as the traditional wireless. Just to give you a basic idea, in the traditional network, what happens, like if you're a little bit aware of the wireless, we have access points. The user basically connects to the access point. User sends the traffic to the access point. Since these access points are being managed via this thing called wireless LAN controller, unless we have configured something, the traffic will go to the WLC, and from the WLC it will go towards the other devices. Unless we have configured things such as Flex Connect and everything. This does not happen in the SDA. This is now how SDA deals with the wireless. No, this is not how the wireless traffic will flow in the SDA. When it comes to the wireless, the traffic flows a little bit different in the software-defined access, actually. So you will notice that the way SDA deals with the wireless, you will notice that we don't need to configure multiple policies. Just one policy will work for both wired and wireless network. It is because of how SDA deals with the wireless network, how the wireless traffic is handled in the SDA. Because of that particular thing, we don't need to configure multiple policy. One policy will be same for wired and wireless user. We will notice that later on. As far as the components are concerned, what things we require to build a SDA solution? We require building this next generation SDA solution involves some key foundation elements, some key components, controller-based architecture. Okay, we know that we will require some controllers. We require some controllers such as DNS center, such as wireless LAN controller. If we are going to manage the access points from one centralized point, then we also need the WLC. DNS center will not act as the WLC. DNS center will just interact with the WLC. DNS center is going to send the instructions to the WLC. The WLC is the one which will be responsible to manage all the access points from one centralized place. DNS center is not the WLC, just like the DNS center is not the ICE. DNS center is not the actual policy enforcement engine. The actual policy enforcement engine is still identity services engine. DNS center will push the configurations on the ICE, and ICE will deploy the policies in the network. So we will require, there is a controller-based, since it is a controller-based architecture, that means we require certain controllers such as DNS center, controllers such as WLC. Since it is since we need to configure the policies in our network, policies like who can communicate with whom, what devices can have access to what devices and all. So we will require a policy enforcement engine. Typically, what we are going to use, we will use identity services engine for the same. Network fabric. Every time you hear the word fabric, overlay, typically overlay. Like underlay is already there. We already have our campus network. We already have our campus network built. We already have our access layer, distribution layer, core layer, edge routers. We already have our complete reachability. Now we are going to build a logical network on the top of that, and we are going to call that fabric, SDA fabric, a network fabric. Fabric is overlay. Typically, fabric means overlay. In sometimes you will notice that underlay overlay in combined is known as the fabric, because if the underlay is not there, then overlay of course will not be able to operate. So but typically fabric means overlay. SDA fabric, network fabric, SDA fabric. SDA fabric basically means that we will require some overlay network that will be built on the top of the underlying infrastructure. A programmable interface. What do we mean by that? Programmable interface basically means that we can use these third-party automation tools. We can use automation tools maybe offered by Cisco. We can use automation tools offered by some other vendors. We can use these third-party automation tools, and we can program our campus fabric. We can program our SDA infrastructure with the help of those Python scripting, with the help of those APIs, with the help of those programming. In fact, when we go to the browser and when we navigate through the GUI in the back end, it's still API. Your browser is sending some API calls to the DNS center. DNS center is responding based on the same. It is just we are able to see that from the GUI. In the background, it is all API. Still, it's API. So, what I'm trying to say is that here is your DNS center. A DNS center provides you the GUI access, graphical user interface access. So, what you do, you open a browser. In the browser, you type down the IP address of the DNS center, and it opens a GUI, and you navigate. You basically interact with the DNS center with the help of the GUI. But when we open our browser and we click on a particular thing, in the backend, it's API. Like my browser is sending some API calls to the DNS center, and DNS center is basically sending the response based on that API, and we are able to see that from the GUI. In the backend, it's the API. So if you are good with programming, if you know about programming, if you know about the API, you can leverage those APIs directly. You don't need to use the browser for the same. If maybe you are good with programming, you know how the APIs works. You are a developer, and you know like what is an API, how the APIs work, how can we use these different automation tools to use the API and do the things. Maybe you know all that, so you can just interact with the DNS center using the API. You don't necessarily need to actually you do not necessarily need to like interact with the GUI. Is also one thing. So it has programmable interface. Programmable infrastructure basically means that not only we can interact with the DNS center using the GUI, but we can also interact with the DNS center using the API. Third-party automation tools like automation tool interaction is also awesome. These are like, the main elements. These are the main components that we get inside our SDA solution. These are those components in physical. What is this? What is this controller? Okay. Controller is like DNS center. Controller is like WLC. What is this policy enforcement engine? Here we have our identity services. Where is that? Identity services engine, ICE. What is this like network fabric? Network fabric is created based on the routers and switches that we have in our campus network. So we have some, we have some switches. This is the access layer, distribution layer, core layer, some edge routers and all. This is my campus fabric. Campus fabric is built based on the overlay network. Then we have some programmatic interfaces. That means we can use some other like third-party automation tools to manage our campus network from one centralized point. These are the components that we require from the design point. We require routers and switches. We require access points, wireless LAN controller. If you also have wireless in your network, which of course you will have as a company, as an infrastructure network, you will also have the wireless in your network. Identity services engine to enforce the policy. DNS center controller to manage everything from one centralized point, also known as the catalyst center. Then we will have the routers, we will have the switches, we will have the access point, we will build our physical infrastructure, we will make all the devices reachable to each other. To make the reachability, we will require any protocol. We will require like the protocol to make the reachability. How these devices are supposed to be reachable to each other, we will require some protocol for the same. The protocol that we will require is any protocol. We can use any protocol, EIGRP, OSPF, any protocol. But Cisco recommends that you use what ISI is. ISIS is a preferred protocol for fabric-based technologies. Later, we'll talk about that. ISIS is a preferred protocol for the fabric-based technology. You might notice that in your data center network also, you use ISIS protocol actually. In your service provider net, service provider is not a fabric-based, but in the service provider core, you will also notice the use of the ISIS protocol. In the enterprise network, we were not using ISIS protocol. We were using like EIGRP, we were using like OSPF. But since nowadays we talk about the software-defined networking, we talk about software-defined fabric, we talk about software-defined branch, Cisco recommends that you go for ISIS. Not a hard and fast rule, not like you have to change the protocol to ISIS, but Cisco recommends that you have the ISIS. Why, how, and all these things we'll cover later on. So why we require any IGP? We require the IGP so that the reachability is there. We require the IGP, we require the interior gateway protocols so that we can make the reachability between all these devices that we have in the campus fabric. Of course, these devices should also be reachable to the ICE. These devices should also be reachable to the WLC. These devices should also be reachable to the DNS center. If the reachability is not there, then DNS center will not be able to do anything. ICE will not be able to do anything. WLC will not be able to do anything. Reachability you have to make. And that is your problem, how you are going to make the reachability. Maybe the identity services engine, maybe the DNS center and the wireless LAN controller is somewhere in the data center. And data center is in some remote location. And our devices, our campus fabric is in some remote location. How you are going to make the reachability is your problem. How you are going to make all these devices reachable to the DNS center, how you are going to make these devices reachable to the ICE, how you are going to make all these access points reachable to the WLC is your problem. I mean, you have to make the reachability, and for the reachability, you are going to use you can use whatever protocol you want to use, but Cisco recommends that we have the ISIS. Not specifically that we have to migrate
One
everything to
question.
ISIS, but you can use any protocol. Cisco recommends that we have the ISIS.
I have one question.
Yes.
If you configure any IGP to enable the communication in between those devices, like a switch, controller, access point, okay? But when we integrate it with the controller is pushing his own software or the own configuration to the device.
Yes, correct.
After that, will it get overlap to the IGP, or IGP will be on separate plane and the configuration from the controller will get pushed on it is on the different?
Same thing. Concept of underlay overlay. Whatever configurations DNS Center will push to make the campus fabric, whatever configuration, whatever information, whatever configurations DNS Center is going to push on all the devices to make it a campus fabric, a software-defined fabric, that is all part of the overlay. So your existing configuration will remain as it is. Your existing IGP configurations, the reachability and everything will remain as it is.
Okay. So it will build a virtual tunnel in between the devices.
Yes, correct. Okay. Overlay built based on the tunnel, and here is the protocol that is used to build the tunnels.
Understood.
VXLAN is one of the protocol. List is one protocol. These two protocols will be used to build the tunnels, between the devices, and the traffic will move via the tunnels from one device to another device. Basically, with the help of these protocols, the overlay will be built. And these configurations will be pushed from the DNS Center. So you technically you don't need to know a lot about the VXLAN. Technically, you don't need to know a lot about the list. Just the basic things which we will cover throughout the content. You don't need to go through in and out like complete VXLAN, complete list. You don't need to study. Why? Because these configurations will be pushed by the DNS Center in a complete automated way. Basically, whatever configurations are required to make the campus fabric work, DNA will push it. Whatever configurations, like whatever configurations of the VXLAN, whatever configurations of the list, whatever configurations are required to make the SDA fabric work, whatever configurations are required to make this campus fabric work will be pushed by the DNS Center, and that all will be part of the underlay. You can build using whatever protocol you want. Cisco recommends that we have the ISIS. It is because when later on we will cover that, but it is mostly like because when, let's say for example, something is not working and you raise a Cisco tag case and you tell them that okay, here is the issue, they expect to see ISIS. They expect to see ISIS in the underlay. So that is one of the things. From the T-shoot point of view, from the configuration point of view, it is ISIS. Also, when we talk about the, we covered a concept called, or let me tell you, there is a concept called LAN automation. In the DNS Center, in the SDA, there is a concept called LAN automation. LAN automation basically says that you just deploy one device. Just deploy one device. Rest of the LAN network I will build myself. You just deploy one device. Make this device reachable to the DNS Center. Add this device to the DNS Center. Make this device reachable to the DNS Center. And rest of the LAN network, I will discover the devices automatically. I will build the underlay network for you. So you don't even need to build the underlay network. I will do it myself. DNS Center says that. LAN automation concept that we have in the DNS Center, LAN automation says that that DNS Center can build the underlay network automatically. We don't even need to build I will show you. We don't even need to build the underlay network manually. We don't need to do that. Complete automatically. When the DNS Center does that, when the DNS Center builds the underlay network automatically, when we use this LAN automation, you will notice that the DNS Center will build the network based on the protocol called ISIS. It is how it is designed to do. When the DNS Center builds the underlying infrastructure automatically, it will use the protocol like ISIS. Now let's say here you are using what, EIGRP, and suddenly you installed a few more devices and you want to use the LAN automation to build the underlay network automatically. DNS Center can do that, no problem. But then here it will be ISIS and here it will be EIGRP. Then you have to manage two different protocols. You have to do redistribution and everything to make the reachability and everything. That's why they say go for ISIS. because later on when someday you start using the LAN automation and everything, if you let the DNS center build the underlying network for you, they will use ISS. So that like you don't have to manage like multiple protocols. Not a hard and fast rule that you have to go for the ISS, but it is recommended actually. LAN automation and everything is also covered later on in our. So any protocol that you can use, any IGP protocol that you can use, that you want to use to build the underlying network, any protocol. Make the reachability between the devices, and the DNS center and everything. Then the DNS center will build the campus fabric using the overlay protocols such as VXLAN and WISP. Now, VXLAN is the data plane protocol, WISP is the control plane protocol. Is discussed in very detail later on. And of course, if you want to enforce the policy, we will use like the TrustSec, CTS, Cisco TrustSec for the policy enforcement. ICE basically. Identity Services Engine will be used to enforce the policy in our SDA. These are the components, hardware one, and these are the protocols that we will require to actually make the entire SDA solution. We will still require like manual configurations. Why? So that we can have the reachability from the devices to the DNS. We will still require. It's not like it will completely. If you are not going for LAN automation, then you have to do it. If you go for the concept called LAN automation, then DNS center will do that for you as well. Like you don't even need to build the underlying network by yourself. That is again advantage. Whatever you choose, whatever option you do. Either you can build the underlying network manually or let the DNS center build the underlying network for you. It will be responsible to convert these links into L3, configure the IP, configure the routing, configure the default route, everything it will do automatically. And let's not even forget about the PNP. Let's say we are not using the LAN automation. I'm not going to build I already built my underlying network. I already did that. I already built my underlying network using EIGRP. That's done. It is already reachable and everything. Now I have to install a new device. I have to add a new switch in the network. And I want that switch should be automatically added into the DNS center. PNP, plug and play. We can use PNP concept, plug and play, PNP services we can use, and PNP will be used to automatically onboard the switch into the fabric. Not the LAN automation. LAN automation is to build the underlying LAN infrastructure. PNP is just to discover it. I can discover one or two devices, and those devices can now be managed by the DNS center, and all the configurations and everything can be pushed onto those devices automatically. So that is also one benefit. If you have to deploy 10, 20 devices, just unbox those devices, connect it into your network, and that's it. Power on. That's it. Of course, like the device will discover the DNS center using the PNP plug and play services, and on the DNS center devices will be now. We can see those devices. We can configure, provision. We can do all the things, rest of the things from the DNS center itself. We don't need to manually install like each and every device one by one.
Okay, is the solution available for Campus Fabric, which is already deployed?
That is fine.
Okay, but
all you have to
that underlying configuration, IP and VLAN, basic
if you
VLAN
have,
or the IP configuration.
That is available. All you need to make sure that we have compatible devices with you. All you need to make sure that like you have configured at least one of the device that is reachable to the DNS center. Rest will be built automatically. Or if you have already built the underlying network using whatever protocol, then you can discover a new device as well with the help of the PNP. Both the options are available for the campus.
Interface configuration, for example, uplink and the basic. So it will be get copied from the neighbor device and get it pushed, or how? I'm worried about the underlying network.
I'm also talking about the underlay. If you're talking about the LAN automation, which is responsible to build the underlay network automatically, everything will be done automatically. Like it will automatically configure up IP address, routing, and everything. It will do automatically. Of course, we will need to do something on the DNS center for the same, but it will do that automatically. How it gets the IP, how it configures the protocol, that all is discussed in the underlay, but it will be done completely automatically. You do not need to touch these devices. You will not need to touch these devices. You just need to make sure that at least one of the device is reachable to the DNS center. DNS center will use that device as the base device. DNS center will use that device as the seed device, and from there it will start doing the configuration on rest of the devices.
Okay, understood.
Yeah. Which again, we will do practically as well later on, but this is how it is. This is how the entire, these are the components, these are the hardware resources that we require, and these are the protocols that we will typically use in our SDA infrastructure. One by one, we will cover about every. It's not like you can have random routers. It's not like you can have random switches. It's not like you can have like any ICE. It's not like you can have any AP, any WLC. No, there's a proper compatibility matrix. You only can have like some compatible devices only. Like you cannot have like any random router running iOS. No. Like some soft, like hardware requirement, hardware and software compatibility has to be checked as well. So, that we will discuss later on. But again, it's not like you can have like just any random router switches, random APs, random WLCs, random ICE. Like you are using 2.6 maybe, and you are using like a DNS Center specific version. It will not work. So there is a proper compatibility matrix. There is a proper compatibility chart that, okay, this version of the DNS Center is compatible with this ICE, this WLC, this like router. So you have to purchase the router, or you have to do the software upgrades on the router, switches, APs, WLCs, respectively. So overall, Cisco SDA, Cisco Software-Defined Access, is an enterprise networking solution based on intent. Intent-based network views the network as a single system that translates, validates the business goals into the network, and returns actionable action. So we will interact with the controller. We will define our intent on the controller, and controller is going to push that intent. Controller is going to convert that intent into the configuration, and controller is going to push that intent on all these devices that we have in our infrastructure. Cisco SDA is composed of two main things: Cisco Campus Fabric and DNS Center. DNS Center is the hardware appliance that we require to manage the campus fabric from a centralized point, and the campus fabric. Fabric typically means overlay. So whenever we hear the word fabric, it typically is going to refer to the overlay network. The traditional physical network connecting the devices is known as the underlay. Here, it is all going to be known as the underlying infrastructure, and a logical network built on the top of the physical infrastructure. An overlay network is referred to as the fabric. Overlay is what we refer to as the fabric. It is a logical network that is placed on the top of the physical underlay, and it is built with the help of the tunnel. So there will be a tunnel from this switch to this switch. There will be a tunnel from this switch to this switch, and that tunnel will be used to send the traffic. That tunnel will be used to send the. So SDA, like Cisco SDA, will require two main components: overlay and the DNS Center. In fact, overlay will be built with the help of the DNS. Like we will not do the VXLAN configuration manually. We will not do the Lisp configuration manually. That will be done automatically. No need to repeat these things again and again. We get better visibility of the network with the help of the Cisco SDA. We can segment the network based on the group, like group of users, IoT user, corporate user, like guest users. In the corporate user, we have HR, finance. We have the concept called VRF. We have the concept called scalable group tag, SGTs. So we can use a few concepts to do a segmentation in the network, like micro segmentation, macro segmentation things are available in the Cisco SDA. We can configure like one policy, and that policy will remain consistent for wired and wireless both the users. Apart from that, we can automatically onboard the devices using PNP. We can build generally network using the LAN automation. We can integrate the wireless. We can integrate the ICE, umbrella. We can integrate a lot of other external systems with the DNS Center as well. These are four main things. These are four main things that the DNS Center can do. From the DNS Center, we can design the network. We can enforce the policy. We can configure the devices. We can build the fabric, and we can do the monitoring. These are four main workflows of the DNS Center. Apart from that, we can integrate third-party tools. We can integrate third-party systems in the DNS Center as well. Right? So we can do segmentation like IoT devices, employee network. In the employee, we have HR, finance. HR should be able to communicate. HR should not be able to communicate with the finance. All kind of policies we can enforce. in the, like, for example, we have some smart bulbs, we have CCTV cameras. I don't want these two to communicate to each other. I can configure the policies for the same. Then we can we can have wireless LAN controller. We can have like the access points in our network as well. We can do we can build our campus fabric as per our requirement. Then we will use the DNS center to manage that campus fabric from one centralized point. That is the whole SDA solution. That is the whole SDA concept that we will go through in throughout the project. Building on the foundation of industry-leading capabilities, Cisco SDA can now deliver whatever. So increased visibility, we can determine, create, apply network policies, zero trust security for the network. Until a device is properly authenticated, it is not supposed to join the network. Until the user is properly authenticated, I don't trust any device in the network. The device must be properly authenticated from the ICE. Once, if a user is trying to access the network resources, the user first must be authenticated. Then only the user should be allowed to access the network. And that authentication can be done with the help of the identity services in there. User, let's say if there is a user, it has connected itself via the wireless access point, and the user is roaming. User has roamed from the first floor to the second floor to the third floor, and the user is basically roaming from one access point to the access point to the access point, but its network is not disconnected. We can manage the roaming. We can manage things such as, for example, user mobility with the help of the SDA in much more better way as compared to the traditional network. User mobility is handled by the SDA as well very efficiently as compared to the traditional. So user can be on the first floor, second floor, third floor. User can roam from one place to the place and still be connected to the same network without any problems. Still be subjected to the same policies, no matter if it is on the first floor AP, second floor AP, or third floor AP. It does not matter. Guest access, like we can have different VRF, we can have different segment for our guest users. For the guest users, we have direct internet access. The guest user traffic will not go to the data center. The guest user traffic is not supposed to interact with the IoT. The guest users are not supposed to interact with the corporate users. We have configured proper policies for the same. We have configured same kind of policies for our IoT devices, CCTV cameras, smart bulbs, other applications, PCI compliances, and all those things. Basically, we can do the monitor troubleshooting from one centralized point. We can integrate our cloud data center branch integration. We can do all those things within the scope of the Cisco Software-Defined Access. These are some key benefits that you get in the Cisco Software-Defined. Cisco SDA gives IT time back dramatically. So 67% saving in network provisioning time, 80% less time during the issue resolution. We also saw that in the last class. In the last class, we reported, DNS Center reported that there is a host flapping issue. Looks like there is some issue in certain VLAN. So we just used that artificial intelligence machine learning, and the DNS Center was able to tell us that there is a loop in VLAN 31. And what you should do to fix that loop, it also suggested some actions for the same. So if that was not there, then we will need to log into the switches one by one, and we need to execute the commands manually. Then we will find out the same exact thing, that there is a STP is not running for VLAN 30. We'll find out the same thing, but it will take time. Here, like 80% less time in the issue resolution. They say that 5-year return of investment is approximately, this is again from this quote itself, like might be true, might not be true. So they say that approximately 462% 5-year return of investment. So at the time when you deploy the SDA, it is not a very cost effective solution. You have to purchase the DNS center, you have to purchase the compatible devices, you have to purchase the compatible, you have to have the ICE, you have to have the WLC, access point, router, switches. So at the time of deploying the DNS center, at the time of deploying the SDA, it might not be a very cost effective solution. One DNS center will cost you a lot. Like if you have one DNS center, it will cost you a lot. And for the HA and everything, they recommend having at least 3 DNS centers. So purchasing 3 DNS center, deploying them in a cluster, and if you want to go for good redundancy, then a cluster of 2, like one in one geolocation, one in another geolocation, 3 DNS center, 3 DNS center. Then clustering we need to do, HA, disaster recovery. So the at the time of the deployment, it's not a very cost-effective solution. But when we compare it with the amount of resources that we spend in troubleshooting, managing, monitoring, overall return of investment for next 5-10 years is going to be approximately this much. That as per system. Right. since the policies are centralized, managed from the IaaS and everything for both wired user, wireless user, there will be less security breaches as compared to the like typical traditional network, reduce cost of operation, more efficient network management stuff. Like we don't need like a lot of people to manage the network now. We just need 5-6 people who can work on the DNAC network. So management is going to be easy as well. So we will both save money and we will save some time if you are going for the Cisco SDA solution. That's what they say. Rest you can decide yourself. Like once the content is done, you will also be able to like understand the benefits, use cases, and everything. Then you can decide like how much of this thing is true. I have seen like a lot of companies moving to the SDA. A lot of companies have clients for the SDA. Colleges are using the SDA solution. Colleges like campuses like their college campus is also using like the SDA solution. Company campus is using the SDA solution. Sooner, since prime infrastructure is going to go like end of support sooner or later, so companies they will have to use some other controller for the same. So sooner or later you will have to study SDA anyway, until some other controller comes in. Oh, by the way, if you don't want to make things this much complex, go for Meraki. If you do not want to make things like this much complex, go for Meraki. Meraki, like it is cloud based completely. So you purchase Meraki compatible. You purchase the devices like MX, for example. Go through the Meraki devices. You can purchase like different Meraki devices, and you can manage the devices directly from the Meraki dashboard.
I mean, Meraki controller is in cloud, and it will be a managed by devices by in the cloud.
There is no controller, I would say. Everything like, of course, there is a Meraki controller, there is a Meraki server running on the cloud and all. But what happens like when you purchase a Meraki device, let's say a firewall, you purchase it, a wireless access point, wireless like device AP, for example, you purchase it, install it in your premises, make it internet reachable. It will go to the Meraki cloud. It will register itself using the chassis ID serial number, and that's it. Manage everything from the cloud. So it might not give you that much flexibility as we want, but still, for small businesses, very good. Meraki is a very good solution. For WAN, like it is all, I would say, not completely, but it is almost complete solution for small businesses. They have different products. They have like you go through the Meraki portfolio and you will know.
Yeah, in that box, firewall and all.
They will have different appliances. They have like firewall appliances. They have like access points. They have different products, just like router switches. So they have different products. It's not like a common box. There are different boxes. There are different products. You purchase it. The point is that you don't need to manage those boxes one by one on premises. You can manage everything from the Meraki cloud. So that thing, like you can purchase the Meraki AP, manage it directly from the cloud. It is just a matter of dashboard, na? As long as that Meraki access point is reachable to the internet, all good. You can manage it from the home. You can manage it from the campus. Whatever. It is a very good solution. In fact, these switches, these Catalyst 9000 series switches, these can also be managed by. There is one command. We need to execute one command, and those switches can be managed by the Meraki. The degree of control. What things we can control? That you have to explore. That you have to check. You might not get as much facilities as the DNS center offers, as the vManage offers. You might not get that much functionalities. You might not get that. Otherwise, why would they have a different solution then? So Meraki is also very good. Meraki is a very good SDN solution for a small, I would say small to medium businesses. It's a very good solution. But if you have like medium to large network, you will go for the Catalyst SD-WAN, you will go for the SDA. This slide says that you don't need to start everything from the scratch. If you already have deployed your existing infrastructure, then you don't need to start everything from the scratch actually. Like, you can migrate from the traditional to the SDA infrastructure. Parallel migration, incremental migration, there are different migration techniques. There is a migration guide. Like, just like we have the migration guide for the SD-WAN, we also have a migration guide for the SDA. So this basically says that if you are deploying a new network, complete new network, deploy it based on the SDA. But if you already have some existing infrastructure, you can migrate it slowly throughout the time into the SDA. And the, if some part of your network is traditional and some part of your network is what? SDA. There can also be a communication between them. We can also have the interoperability between the SDA, SD branch, normal branch. We can have, not directly, but we will have some like interoperability. We'll talk about that later on. There is a concept called L3 handoff, L2 handoff concept. So that L3, L2 handoff concept enables us to have the SD branch and still be able to interact with the traditional devices, traditional branches, traditional data center headquarters. So it's not like you have to, it's not, the SDA is not only for greenfield deployment, it's also for the brownfield deployment. So greenfield basically means that we are deploying everything from the scratch. If you are doing that, if let's say you have to set up a new branch and you have to purchase the new devices and everything, then go to the Cisco website, check the compatibility matrix and purchase the compatible devices right away. Right. And then you deploy, you build the branch based on the ST. But if you already have deployed your infrastructure, you already have some existing infrastructure, then you can slowly migrate from the traditional to the SDA infrastructure. So that is this. It's not like you have to completely wipe everything from and then you have to start from the scratch. No, it's not like that. So migration is also possible with minimum disruption to the users and connected devices. We can slowly we can migrate from the traditional to the SDA network with the minimum disruption to their users and the connected devices. This all is in chapter 1. If you go through that official book that we discussed in the last day, it's all in chapter 1. This is complete chapter 1. Chapter 1 basically why we need SDA, what is the requirement of the SDA. So they will tell you like the exact same thing. What are the challenges in the traditional network, security challenges, network operation challenges, deployment challenges, troubleshooting challenges, like, all those things. And then how the SDA is going to benefit in all these things. So the basics, like, you can, if you want to know, I guess this is enough. But if you still want to go, like, in more detail, if you want to know more about it, definitely you can look up this document. The SDA, Cisco Software-Defined Access, the SDA official book. You can definitely go for it and read the chapter 1. Today's network and the drivers for the changes. Then, like, in this chapter, they just describe like why do we need like SDA. Half of this book is like why we created the DNS center. Half of this book. Who created the DNS center? Like, okay, there were these 4 engineers, this, that, So half of this book is basically like, the why we created the DNS center. So just you can go through it. You will get the exact same thing, same exact concepts, like, so common businesses and IT trends. Devices are moving to the cloud, like, softwares are moving to the cloud. Bring your own device concept is there. Applications nowadays require high bandwidth. Wireless first connectivity is becoming new model. Like everyone is trying to nowadays connect with the help of the wireless, not the wired. No one wants wired connectivity. So go through it. Like, I'm not saying that it's like it's a good book. Like, you can go to the chapter 1 to get in more detail about the information. The basics are done. Basics, like, all the things that we should know from the basics point of view, that is now done. Any questions, any point, any doubts, let me know. This is just like why we need SDA. Now we'll go in the technicals. Now we'll talk about the technical, like what devices we require, what are these like architectural components and everything. Now we'll go in the technical aspects of the SDA. Right. So next, let's talk about the architecture. Architecture का मतलब ये है कि, so architecture basically means from the design point of view. From the design point of view, if you have to build the SDA network, what components basically you will require? Like, from the architectural point of view, how can we build the SDA infrastructure? It basically consists of some layers, some devices, roles, protocols, whatever devices we will use in the SDA infrastructure, whatever like protocols we will use in the SDA infrastructure, we will set the roles onto the devices in the SDA infrastructure. So let's talk about that actually. So from the architectural point of view, we have like 4 layers in the SDA. When we build the SDA infrastructure, when we build the SDA network, we have like 4 layers. In 4 layers, we are going to build our SDA infrastructure. Like just like in OSI model, we have 7 layers. In the TCP/IP, we have 4 layers. Then we have the 2-tier design, 3-tier design. In the 2-tier, we have 2 layers. In the 3-tier, we have 3 layers. So from the SDA design point of view, from the SDA architectural point of view, we have like 4 layers. We have the physical layer, network layer, controller layer, and the management layer. We have like 4 layers from the SDA architectural point of view. Every device, every layer has set of devices and or protocols roles. So we will have for example, the physical layer has physical devices, and we are going to set several rules onto those devices. Roles, for example, what devices are the edge devices? What devices are the border devices? What devices are the intermediate devices? What devices are the, like, we are going to set the rules. We are going to purchase physical devices. We are going to connect those physical devices in the SDA fabric. We are going to build the SDA fabric based on those physical devices that we have purchased. And then we are going to set the rules onto those devices. Physical layer has physical devices and roles set on those devices. So network layer, for example, deals with the underlay and the overlay network. Like once we have purchased the devices and we have done all the connectivity, then we need to run the protocols. Whatever protocols we need to build our underlay network, whatever protocols we need to build our overlay network, it comes under the network layer. Protocols such as like RIP-I, GRP, OSPF, the underlay, ISIS, the underlay, the protocols such as VXLAN list in the overlay, all that thing will come into the network layer. Controller layer is basically the SDA control. Whatever controllers that we use in the SDA network. Controllers such as, for example, DNS center. Controllers such as, for example, wireless LAN controller. ICE is basically part of the physical layer, but they also include it in the controller layer. So controller layer includes the controllers that we use in the SDA infrastructure. Controllers such as like DNS center, controllers such as ICE, controllers such as WLC, wireless LAN controller. And of course, how we interact with these controllers. How we are going to interact with these controllers. Are we going to use GUI, graphical interface, to interact with these controllers, or are we going to use APIs, management layer? Management layer deals with like how we are going to, management layer basically deals like how we are going to manage these controllers. Management layer basically deals like how the device is going to manage these controllers. So physical layer will consist of physical devices. Physical layer will consist of physical devices that we will purchase and install. Once we have purchased and installed these physical devices, we have done all the cablings and everything. Then we are going to run the protocols in the underlay, protocols in the overlay to make the devices reachable to each other, to make the devices reachable to the controller. Then controller is going to build the overlay network using the VXLAN, using the list, whatever. Controller layer includes the controller that we will use in our SDA fabric, such as DNS center, WLC, ICE, and the management layer basically deals with like how we interact with those particular controllers. So we have 4 layers: devices, roles, protocols, all those things we have in these 4-layered architecture of the Cisco Software-Defined Access. So Cisco SDA, Cisco Software-Defined Access, has these 4 layers from the architecture point of view. Now, one by one, we'll talk about each and every layer. And by the end of the management layer, half of our content will be done. So one by one, we'll talk about now the physical layer, network layer, controller layer, management layer. Ideally, we should start from the controller layer, the DNS center controller. But let's start with the physical layer, then after we will see. First, we will purchase the physical devices, then we will build the underlay network, then we will talk about the controller. So that's why physical, network, then controller. The very first layer that we have in the SDA architecture is, and by the way, these all things are there in the book. Like it's not like I'm saying that these are 4 layers. It is in the book. It is in the official book that, okay, from the design point of view, these are 4 layers. We can design our SDA infrastructure based on these 4 layers. So the very first layer that we have in the SDA infrastructure is referred to as the physical layer. Physical layer consists of devices, roles that we can set on those devices. So physical layer consists of devices and the roles that we can set on those devices. So as the name suggests, physical layer consists of physical devices that we can use to build our SDA network. And these devices will be connected via some cables, wires, and everything. You can use twisted pair, fiber optical, whatever. We are going to configure the IP address on all these devices. We are going to make these devices reachable to each other. And then we are going to make these devices reachable to our controller. A reachability part is under the network layer. So at the moment, we just need to talk about the physical devices. We just need to talk about the devices that are compatible in our SDA solution. So as the name suggests, physical layer consists of the physical devices that we use to build our SDA network. Once we purchase the devices and we build our network with the help of these devices, we done the cables and everything, then we are going to set the roles on these devices. In this design, this is the access layer, this is the distribution layer, this is the core layer switches. In this design, we are going to set the roles. Once we have built our network, then we are going to set the roles on all these devices. Every device in the SDA fabric will have some. All the devices that are part of the SDA fabric, they will have some. Like DNS Center is going to push necessary configurations to make that device act as the edge, control, border, whatever. But there will be a role set onto the device. In the SDA fabric, all these devices are set with a certain, all these devices are assigned with a certain role, and they behave based on the role that they have been assigned. Different devices that we have in our SDA infrastructure, different devices that we have in our SDA infrastructure, they will have different roles in the fabric, and they will behave based on the roles that they have been assigned.